Welcome to Learn Python. The instruction says press the gray Run button in the bottom right of your screen to see the code's output. Let's do that. This text is printed. Continuing on with the instructions, let's build Fantasy Quest, a text-based game. We need to prompt the players of Fantasy Quest to create a name for their characters. Edit the code so that it prints enter a character name. Then press the blue Submit button to check your work. I'm going to take a moment to point out that Python has nice simple syntax. So we just type print and then a parenthesis, then a quote to denote what's going to be printed, an end quote after what we want to be printed, an end parenthesis, and that's all. We can submit that. Hooray! Next one. Fix your first bug. I like this approach where they're giving you a bug to fix. That seems like a good pedagogy thing. It says XP boost. Okay, that's what that's telling me. Combat in Fantasy Quest isn't working as intended. It appears that players are gaining health when attacked instead of losing it. So this is good. This is very to the point, and it's making you read and think about the code. Can I bring this over here? Yes, I can. I don't want to decrease the font size really anymore. So sword damage equals 10, player health equals 100, health after attack equals player health plus sword damage. That looks like an error, but let's run it. And we can see the output says Lalafred's health is 100. Lalafred is hit by a sword for 10 damage. Lalafred's health is now 110. So just from the output, we can see that that's wrong. And we can also reason that sword damage should subtract health. Let's run it again, see if it makes more sense. Yes, it does. And let's submit. Reached level 30. Cool. The console. So this is talking about the console in the context of this programming course, I think. It says the console is a panel that displays important messages like errors or the text output of a program. If we want to see what's happening in our code, we need to print it to the console using the print function. We'll learn more about functions later, but for now, just know that the print function will print anything you put inside parentheses. So print, quote, anything you put inside. We can run that, and sure enough, it prints it out. Very good. Assignment. We need to tell our new players how to move their character. Print the following text to the console. Use the arrow keys to move. Not error. So I'm telling it use the arrow keys to move. Let's submit this. I'm enjoying all the shiny bits that they've added recently. Okay. What is Python? Thousands of students start their coding journey right here with Python. I actually started with Python when I decided I was going to go professionally into programming. I had seen a little bit of LabVIEW and MATLAB and C and Mathematica before then, which actually sounds like a lot now that I say it all in one go. But when I really decided to get serious about programming, it was Python that I decided to learn. And Boot.dev says, we think it's the best programming language to get started with. Python is famous for being a simple language that's easy to read and write. However, just because it's simple doesn't mean it's not useful. Python is an extremely popular language in the industry and is well known for backend web servers, DevOps and cloud engineering, machine learning, scripting and automation, and etc. On the other hand, it's not particularly well known for front-end work. Well, it's possible to do so. Python isn't typically used to build visual user interfaces. Yeah, I haven't seen a lot of that myself. And there we have a quiz for reading comprehension. Python is not often used in front-end apps. Correct, I earned XP. Fun. Python is known for being simple to read and write. Very good. What is code? Code is just a series of instructions that computers can follow. Computers obey each instruction one after another. Programs can be comprised of many instructions. Oh, I forgot my timer. Like many, like millions. What do we have here? One of the most common instructions in coding is the addition instruction. Printing numbers. Print can print text using quotes. So here's our example of that. Print text, not submit, I just want to run this. But it can also print numbers without quotes. Well, I'm going to be churlish and show that it can print numbers with quotes as well. But now we show that it can print numbers, number 1, number 2, number 3, and so on. Unfortunately, it can't print the number E without parentheses. Without quotes. What's the error? Name E is not defined. I guess we could probably, I'm going a little far afield here, but this might be fun. Import math, print math dot E. Let's see if that works. Yeah, 2.718 and so on. Sorry for that jump off of the main course of things. Let's get this looking a little better. And you can do math directly inside the parentheses. Print 3 plus 5 should be 8. Got it. Assignment. It's common in video games to do basic addition. For example, we may need to calculate the additional damage a sword deals when it is enchanted with a spell. Our hero's sword does 250 normally, but does an additional 75 damage when it's enchanted. Calculate and print the result of 250 plus 75. I'm adding spaces in between the numbers, even though I don't strictly have to. Let's prove that I don't have to. Yeah, it still gives a good result. And it gives the same result regardless if the spaces are not. But it looks better with the spaces, so I will include them. Now submit. That's good. Multiple instructions. Code runs in order starting at the top of the program. For example, print this runs first, print this runs second, print this runs last. I'm going to be silly and rearrange this just to prove that Python doesn't care whether what it's doing makes any sense. If I run this, we have this prints second, this prints first, this prints last. We can do that because Python is just going to do what we tell it to. Assignment. The dialogue in our game needs to be printed in the correct order. In the first level, our hero encounters a talking owl named Jax. Let's display their conversation to the user through text. Rearrange the code so that it prints in the following order. Let's reset the code. Yes, I want to reset the code. We put Jax Baka first, hero ... Jax says something, and then hero says something. Okay, we have Jax says something, hero says something, Jax says something, hero says something. We can submit this. Very good. So code lines run in order top to bottom. Syntax errors. Syntax is jargon for valid code that the computer can understand. For example, print hello world is invalid syntax because prnt is not a valid function. Print is spelled incorrectly. As a result, an error will be thrown and the code won't execute. Let's run it with print and see what happens. Python error traceback most recent call last. File, this is interesting. Eval code, code runner, coroutine, eval. Anyway, the important thing is at the bottom, name error, prnt is not defined. I wonder if I can do something ridiculous here. Prnt equals print. Can I run that? And now print is defined. Oh, that's fun and ridiculous. Okay, reset the code. Okay. There's a bug in our game. Our players are getting mad because they pay us $20 a month to have access to Fantasy Quest. Find the syntax error in the code and correct it. Let's run the code. And it says print is not defined. And rather than correct the error directly, I'm going to try and walk around it and see if this allows me to pass. I'm sure it's not the solution they're looking for, but let's see. Oh, I did pass with that. That's excellent. I'm going to screen cap this and share that in the Discord to show that I got away with something silly. Syntax errors. So we have a little bit of discussion of syntax here. A coding language's syntax makes up the rules that define what properly structured expressions and statements look like in that language. For example, in Python, the following would be considered correct syntax. Print hello world. While in a different programming language like Go, the correct syntax would be fmt.println hello world. There's an example of Python being simpler to write than something like Go. Code can have many different problems that prevent it from working as intended. Some examples include a bug in the logic. For example, a program that should add numbers multiplies them instead. A problem with speed. A program that calculates how to play the perfect game of chess might never be able to finish because it requires too many calculations. It used to be that was a problem for chess computers, and it was a big deal when computers were able to do enough calculations to win a chess game. These days, chess is pretty well solved, so with the computers that we have easy access to. Or it could be a problem with syntax. This is the most common problem for new developers. Luckily, the Python interpreter will try to give you a descriptive error message in the console to help you find the problem. Syntax definition. I'm looking over these options, and I think the answer is valid code in a programming language. Notice that code that produces the correct output would be incorrect because it's possible to have correct syntax but incorrect logic. We actually saw that on a few pages back when I printed this print second before this prints first. The syntax was fine, but the logic of the program didn't make any sense. Okay, valid code in a programming language, got it. Syntax error codes. What happens if you try to run code with invalid syntax? What are our options here? I think these might be fun to read through. We have the computer will freeze. You will be provided a syntax error message and the code won't execute, or the network will disconnect. It'd be a problem if the computer would freeze, and that would make programming kind of scary to learn, but fortunately you'll just be provided with a syntax error message and the code won't execute. Okay, that was chapter 1. We'll take a quick breather and get back into it with variables in chapter 2. So from the course, variables are how we store data in our program. So far, we've been directly printing data by passing it directly into the print function. Now we are going to learn to save data in variables so we can use and change it before we need to print it. A variable is a name that we define that will point to some data. I already did this before with saying print equals print. For example, I could define a new variable called myHeight and set its value to 100. I could also define a variable called myName and set it equal to lane. To creating variables. To create a new variable in Python, we use the following syntax. I'm going to type this out to practice it. My new variable 2 equals 2. Also, this can be called anything equals 3. Assignment, we need to keep track of our player's health, of our hero's health. On the first line of code, create a new variable named player health and set it equal to 1000. So we have here, I'm going to run this just to check. 1000 looks good, so let's submit. Quest complete. Get 12 exercises correct in a row. Cool. We can continue. Okay. Chapter 2, Section 2, Variables vary. Variables are called variables because they can hold any value and that value can change. It varies. For example, the following will print 20. We say acceleration equals 10, then acceleration equals 20, print acceleration, and it's going to print out 20. The explanation goes, the line acceleration equals 20 reassigns the value of acceleration to 20. It overwrites whatever was being held in the acceleration variable before. It's worth mentioning that the equal sign doesn't mean equality in Python. It means assignment. Like assigning a value to a variable, which is different from assignment as in this course is telling me to do something. So the assignment is, we need to reduce our hero's health as they take damage in the game. Before each print function in the provided code, change the value of player health to be 100 less than it was before. I'm going to stick to only things that I've learned so far in this course. So let's test that one. Sure enough, it goes down to 900. And let's just paste that line before we print player health. And here, how many times is this going to happen? That many times. 900, 800, 700, 600. So that's good. Let's submit that. Yay, XP. Let's do some math. Now that we know how to store and change the value of variables, let's do some math. Here are some common examples of mathematical operators in Python syntax. We have sum equals a plus b. Oh, this is an interesting tidbit. Some type of sum. Let's see what it says about type of sum. Oh, I should print that. I'm going to take a screenshot here because I might mention this. It's a little weird that sum is highlighted, but it's because sum is a built-in function or method. Whereas if we try to do this with difference, we find that name error difference is not defined. That's interesting. So that's why we have this sum being highlighted in orange here. Anyway, moving forward, difference equals a minus b. We can write product equal A times B, or for the next one, we can write quotient equals A divided by B. Now on to the assignment. Create a new variable called armor health on line 4. Line 4, oh, I better reset the code. Create a variable armored health on line 4 and set it to player health times armor multiplier. So armored health equals player health times armor multiplier. Let's run that. It should give us 2000. Yep, submit. Let's do some more math. That's a fun title. I think it's a fun title. I don't know if you agree. Creating negative numbers in Python works the way you expected. Just add a minus sign in front of a number. So for that, my negative num equals, let's call it minus 10. Let's print my negative num. It shows it below as minus 10. Reset the code. Assignment. When our hero walks through poison, their health should be reduced. Change the poison damage variable to be negative. Fun fact, computers can do math on really big numbers very quickly. Another fun fact, Python doesn't have a long integer type. It just has an integer type. It's called integer, right? It's print type of player health. Yeah, class int. Okay, I was doubting myself for a second there. Change the poison damage value to be negative. Getting back to the assignment. Run it. It runs. I'll submit it. Yay! Comments. Comments don't run like code, they are ignored by the computer. Comments are useful for adding reminders or explaining what a piece of code does in plain English. So a single line comment example is a hashtag symbol telling us that speed is a variable describing how fast your player moves, speed equal 2. So this is a comment. Multi-line comments, aka doc strings, you can use triple quotes like this. Oh, it surrounded it for me. That's nice. Multi-line comments, aka doc strings, you can use triple quotes to start and end multi-line comments as well. Code found below will print hello world to the console. I would argue that's not a very useful doc string, but we're just doing basic examples here, so that's okay. Assignment. The line 1 in the code, I need to reset the code. Line number 1 in the code was meant to be a comment, but the developer forgot to use the right syntax. Hashtag. Fix the bug by making the first line in the code a comment. Here is where I like that we have the run button, because I can click run. And let's see what the error is. Syntax error. Invalid syntax. That's interesting. I'm surprised it's not a name error. And why is it right there? That's an odd place for it to, unless it's complaining about it. Oh, it's probably complaining about it right there. Let me. Yeah, best sword is what it's complaining about. That makes a lot more sense. Okay. Go back to resetting the code. Fix the bug by putting in the hashtag and run. Okay. Best sword equals scimitar, print best sword, submit. Very good. Variable names. Variable names can't have spaces. They're continuous strings of characters. In Python, you should use snake case. After all, Python is a snake. When creating variable names, it's become the rule of thumb for the language. By way of comparison, camel case is where the beginning of each word, except the first is capitalized. So casing example, no casing, some variable here equal 10. Camel case, some variable here equal 10. Snake case, some variable here equal 10. Which is valid? Camel case. I almost clicked on hero health here, but it's this one. Nice. Variable names. Variable names can't have spaces. They're continuous strings of characters. In Python, you should... Oh, wait. Which is valid? Snake case. I don't want to repeat myself on that whole spiel. Which is valid? Snake case. That's this one. Okay, basic variable types. In Python, there are several basic data types, and I wonder which types they're going to start out with. Strings are raw text in coding speak. They are called strings because they are a list of characters strung together. Strings are declared in Python by using single quotes or double quotes. That said, for consistency's sake, we prefer double quotes. I've seen single quotes used sort of a lot in a lot of places, but I will take their word for it that here at Boot.dev, we prefer double quotes. So name with single quotes and name with double quotes. Numeric types. Numbers aren't surrounded by quotes when created, but they can have decimals and negative signs. So x equals 5, that creates an integer. Y equal -5, that creates also an integer. We can print type of x and it'll tell us int. Then we can go forward and say x equals 5.2, y equals -5.2. Let's print type of x, comma, new line. And we should see print. Class int and class float. A float is a number with a decimal. And this is something worth mentioning about Python. As a Python programmer, you don't declare what the type is. You give Python data, and Python decides what the type should be. What if you had something that was equal to 5, but you wanted it to be a float? Well, you would have to say x equal 5.0. And now we can see that from this first print, we get class float. Boolean type. A Boolean or bool is a type that can only have one of two values, true or false. As you may have heard, computers really only use ones and zeros. These ones and zeros are just Boolean values. So we have, well, I won't type the code for that, but with 0 equals false and 1 equals true. Although I've heard that in some places, like for operating system stuff, they use 0 as true because 0 is the non-error code. So it's like true that your thing didn't error. It's potentially confusing. But we have is tall equal true. We can print type of is tall. And an interesting note about the design of the language is that the true and false are both capitalized. And I'm not sure why that is, because it seems like you could just as easily have used lowercase true as the keyword for that type, but uppercase true it is. Okay, assignment, fix the code, the bugs in the code to move on, so we need to reset the code. Player health should be an integer. Ah, yes. Player health should be an integer. Player has magic should be a Boolean. So we just have to take away those things. Yo, Doomjaw. Hey, thanks for stopping by. Okay, player health has a class int. Player magic is a bool. Submit. Huh. None-type variable. Not all variables have a value. We can declare an empty variable by setting it to none. Empty equals none. The value of empty in this instance is none until we use the assignment operator equal to give it a value. None is not a specified string. Note that the none type is not the same as a string with a value equal none. My none equal none. My not none equals quote none. And what if we print my none equals double equals? We haven't learned that yet, but I'm going to use it anyway. This is going to be false. Okay, moving on. Assignment. Declare a variable named enemy and set it to none. Don't change the print function. What if I do change below that line? Anyway, enemy equals none. Run, submit. Enemy is none, yo. What if I... Huh, it didn't print. That's interesting. It just printed yo. Anyway, submit. We got this. None type. Like we mentioned in the last exercise, the none keyword is used to define a null variable or object. In Python, the none keyword is an object, which we'll cover later, and it is a data type of the class none type. Why might you use a none value to create bugs? How about as the default value that will be replaced later? I've seen that in code at work for sure. Hey, cool, it didn't count me as incorrect for accidentally on purpose missing that last one. Claim the XP. Continue. Dynamic typing. Python is dynamically typed. All this means is that a variable can store any type, and that type can change. So not only the value can change, we saw that before, but now we're saying that the type of the variable can change, which, by the way, you can't do in some other languages. For example, if I make a number variable, I can later change that variable to be a string. This is valid. Speed equal 5, speed equal quote 5. But just because you can doesn't mean you should. In almost all instances, it's a bad idea to change the type of a variable. The proper thing to do is just to create a new one, Although interestingly, I was seeing the exact opposite pattern in the Learn Rust book the other day. If I remember, maybe I'll link to that, but I probably won't remember. Anyway, speed equal 5, speed description equals quote 5. What if it weren't dynamically typed? Strongly typed languages like Go, which you'll learn in a later course, are strongly typed instead of dynamically typed. In a strongly typed language, if you try to assign a value to a variable of the wrong type, an error would crash the program. If Python were strongly typed, the first example from before would crash on the second line, speed equals quote 5. The computer would give an error along the lines of you can't assign a string value, 5, to a number variable, speed. Is changing the type of a variable generally a good idea? I want to say on Tuesdays, but I'm going to protect this streak of correct answers and say no, it's generally not a good idea. Okay, moving on. Dynamic typing. More about dynamic typing. What kind of typing does Python employ? Reading comprehension check here. It's dynamic. Math with strings. Most of the math operators we went over don't work with strings with the exception of the plus addition operator. When working with strings, the plus operator performs a concatenation. Fancy word. Concatenation is a fancy word that means the joining of two strings. First name is Lane, last name is Wagner. Full name is first name plus last name. Full name now holds the value Lane Wagner. Notice the extra space at the end of lane in the first name variable. This extra space is there to separate the words in the final result, Lane Wagner, with a space. I want to know, so first result equals 1 plus 2. Print result, that should be easy enough to anticipate what it's going to be. Equals 3 plus space plus 4. Print second, oops, I messed up here. Second result. Now third result equals 1 plus 2. Print third result. I wonder if it'll be an error. And finally, fourth result equals 1 plus 2. Let's see what all of these do. Type error. Unsupported operand types for plus, int, and string. Just out of curiosity, is this one going to be okay? Oops. I erased the wrong things. No, I already defined fourth result. Print. Oh, that's an interesting result. That's actually kind of interesting. Let's look back at let's look at this. When we do 1 plus 2, it says type error, unsupported operand types for plus, int, and string. However, when we try it with fourth result, can only concatenate string, not int, to string. I should screen cap these. Because that's interesting how when it started with a string, it tries to concatenate, but I comment those out and move back to these. It says unsupported operand types for plus, int, and string. It's a different error, even though it's the same kind of problem. That's interesting. Okay, go back to reset the code. Assignment. We have a second player in our game. We need to tell each of our players how much health they have left. Edit line 9 to print player 1's health. You have 1200 health using string concatenation and the variables provided. Don't edit above this line. Okay, sentence start plus player 1 health plus sentence end. Then we have edit line 10 to print players 2 health. Sentence start plus player 2 health plus sentence end. Let's see if those look right. You have 1200 health, you have 1100 health. Looks good. After all this time, I still like the fireworks, or I don't know what those are, but I like them. Multivariable declaration. Oh, I forgot about this feature. We can save space when creating many new variables by declaring them on the same line. Sword name, comma, sword damage, comma, sword length equals, quote, Excalibur, comma, 10, comma, 200. Which is the same as sword length equal Excalibur, sword damage equal 10, sword length equal 200. Any number of variables can be declared on the same line, and variables declared on the same line should be related to one another in some way so that the code remains easy to understand. We call code that's easy to understand clean code. I don't think I like this multi-variable declaration on one line. I think it's better to have one thought on each line and not squeeze a bunch of thoughts into one line. But to answer this question, there's no limit. What is clean code? I like the answer code that is easy for developers to read and understand. Okay, we're into chapter 3, computing, with section 1, Python numbers. Python numbers. In Python, numbers without a decimal part are called integers, just like they are in mathematics. Integers are simply whole numbers, positive or negative. For example, 3 and -3 are both examples of integers. Arithmetic can be performed as you'd expect. So addition, 2 plus 1 is 3. Subtraction, 2 minus 1 is 1. Multiplication, 2 times 2 is 4. Division, 3 divided by 2 is 1.5. Well, that's different. And the course says this one is actually a bit different. Division on two integers will actually produce a float. A float is, as you may have guessed, the number type that allows for decimal values. Well, I want to see something here. What about 4 divided by 2? Is that going to be a float? I need to print it. 2.0. It is a float. Interesting. I actually hadn't realized that. I kind of assumed that if it can result in an integer, it will. Okay, assignment. On line 9, create a total damage variable that contains the sum of the different weapons' damage values. Total damage. I'm tempted to make a list out of these, but we'll just do it this way. Sword damage plus paste arrow damage plus paste spear damage plus paste dagger damage plus paste fire damage. And average damage is just going to be, actually I can use total damage divided by, how many are there? There are 5. What does this do? Don't touch below this line. Average damage is 3.0, total damage is 15. Okay, submit. Yay! That's fun. Numbers review. In Python, numbers without a decimal are called integers. Contrast this to JavaScript, where all numbers are just a number type. That's interesting. Integers are simply whole numbers, positive or negative. For example, 3 and -3 are both examples of integers. Floats. A float is, as you may have guessed, the number type that allows for decimal values. My int equal 5, my float equal 5.5. Blank and blank are numerical types in Python. We have integer and float. Floor division. Python has great out-of-the-box support for mathematical operations. This, among other reasons, is why it has had success in artificial intelligence, machine learning, and data science applications. Floor division is like normal division, except the result is floored afterwards, which means the remainder is removed. As you would expect, this means the result is an integer instead of a float. 7 double divide by 2. And interestingly, we have a video here, which I'm not going to jump into at the moment, but if you go through the course, feel free, of course, to watch that. 11 divided by 2 should be 5. Yep. Exponents. Python has built-in support for exponents, something most languages require a math library for. 3 to the power of 2 is 9. What would be 2 to the power of 3? That should be 8. And again, we'll skip past the video. changing in place. It's fairly common to want to change the value of a variable based on its current value. We could have player score equals 4, then player score equals player score plus 1, player score now equals 5. Or player score equals 4, next player score equals player score minus 1, so it now equals 3. Don't let the fact that the expression player score equal player score minus 1 is not a valid mathematical expression be confusing. It doesn't matter, it is valid code. It's valid because the way the expression should be read in English is assign to player score the old value of player score minus 1. That's what I was saying before about this equals sign is an assignment operator, not an equality statement. Assignment. On line 5, add 234340 to the current value of player score. Player score equals player score plus 234340. Player score is that. Cool. Plus equals. Python makes reassignment easy while doing math. In JavaScript or Go, you might be familiar with the plus syntax for incrementing a number variable. In Python, we use the plus equal operator instead. So star rating equals 4, star rating plus equals 1, star rating now equals 5. I'm going to take a moment to pause and point out that that's the same as writing star rating equals star rating plus 1. That's the same as star rating plus equals 1. Back to this. On line 5, use the plus equals operator to add 10 to the player's health. We'll say player health plus equal to 10. Yep. So that's how plus equals works. Oh, scientific notation. As we covered earlier, a float is a positive or negative number with a fractional part. You can add the letter E or E followed by a positive or negative integer to specify that you're using scientific notation. That's interesting that it's a float. Print 16E3 prints 16000.0, or print 7.1E minus 2 prints 0.071. If you're not familiar with scientific notation, it's a way of expressing numbers that are too large or too small to conveniently write normally. In a nutshell, the number following the E specifies how many places to move the decimal to the right for a positive number, or to the left for a negative number. Yeah, that's right. Underscores for readability. Python also allows you to represent large numbers in the decimal format using underscores instead of commas to make it easier to read. That's useful because we had print 16E3. Well, what if we wanted it to be an integer? We might, especially if this was like print A5. Now we have 5 zeros. That's going to be a lot of zeros. So I could put them like that to make the source code easier to read, even though the result is going to be the same. Right? If I print 1.6 with all the zeros without those underscores, same result. Reset the code. Assignment. Due to the constraints of our app server, we have a maximum number of players we can have on a single Fantasy Quest server. Declare a variable on line 1 called max number of players, set it equal to 1024 bunch of zeros using scientific notation. Okay. Max number of players equals 1.024 E 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's a lot of players. And it displays it that way. That's interesting. Okay, we'll submit that. Got it good. Logical operators. You're probably familiar with the logical operators and or. Logical operators deal with Boolean values true and false. The logical and operator requires that both inputs are true in order to return true. I wish I had the coding window here, but I don't. The logical or operator only requires that at least one input is true in order to return true. Well, here we have examples. True and true equals true. True and false equals false. You could also have false and false. So true and false. You could also have false and true equals false. And the other example here is false and false equals false. But with the or true is true because at least one of them is. True or false is true. We could also have false or true is true. And finally, false or false is false. Python syntax, print true and true, print true or false. Nesting with parenthesis. As you would expect, you can nest logical expressions using parenthesis like any other code. Well, we haven't learned about parenthesis in other code yet, but that just means that true or false will execute first, which will be true. But then when we try true and false, we get false. What does the following statement evaluate to? True and true, that much is true. Or, well, because of short circuit evaluation, I already know it's going to be true as the final result. But let's keep looking at this. True and false is false, but true or false is true, so it's true. Sharpshooter Platinum, cool. Okay, we're going to talk about binary numbers now. Binary numbers are just base 2 numbers. They work in the same way as normal base 10 numbers, but with 2 symbols instead of 10. Each 1 in a binary number represents a greater multiple of 2. In a 4-digit binary number, that means you have the 8's place, the 4's place, the 2's place, and the 1's place. Similar to how in decimal you would have the 1000th place, the 100th place, the 10's place, and the 1's place. We have a video about binary numbers. I'm going to breeze past that. What does 1100 represent in decimal? We have 1, 2, 4, 8. So that should be 12. Okay, this is the same thing here, but we have what does 1101 represent in binary? Well, it's 1 more than the last, so it'll be 13. Or what does it represent in decimal? Yeah. Binary numbers, what's the largest number you can store in 5 digits of binary? So in, why did you take away that example? Darn it. 5 digits, count with me. 1s, 2s, 4s, 8s, 16s. 6 digits would be 32, so 1 less than that is 31. Bitwise and operator. Yeah, okay, I guess we'll do this too. Bitwise operators are similar to logical operators, but instead of operating on Boolean values, they apply the same logic to all the bits in a value. For example, say you had the numbers 5 and 7 represented in binary, you could perform a bitwise AND operation that would result in 5. 0101, 0111, 0101. A 1 in binary is the same as true, while 0 is false, so really a bitwise operation is just a bunch of logical operations that are completed in tandem. AND is the bitwise AND operator in Python, so 5 and 7 is 5, while 5 and 2 is 0. So for that example, 0101, 0010, 0000. It doesn't seem very meaningful to be doing bitwise AND on decimal numbers. But okay. Binary notation. When writing a number in binary, the prefix 0b is used to indicate that what follows is a binary number. We have examples of that in the code here. Guild permissions. It's commonplace in backend development to store user permissions as binary values. Think about it. If I have 4 different permissions a user can have, then I can store it as a 4-digit binary number. And if a certain bit is present, I know the permission is enabled. Well, you could really get by with a 2-digit binary number, 0, 1, 1, 0, 1, 1. But can create guild is first bit, can review guild is second bit, can delete guild is third bit, can edit guild is fourth bit. Oh, I see where this is going. Which are represented by 0b0000. For example, if a user only has the can create guild permission, their binary permissions would be 0b1000. A guild which can review guild and can edit guild would be 0b0101. In order to check for, say, the can review guild operation, we can perform a bitwise AND operation on the user's permissions and the enabled can review guild bit 0b0100. If the result is 0b100 again, we know they have that specific permission. Oh, hello, Sammy. Are you a good kitty? Are you going to walk in front of the camera now? And step on the mic table? That's great. Sorry about that noise. What do we have here? So what's going on in the code here? Oh, assignment. Assign a binary value to the user's permission so that the user will have the can review guild permission and the can delete guild permission. Well, let's just do what it says and then we'll think about it. Can review guild is the second bit. Can delete guild is the third bit. So 0b0110. And the outputs just tell us user can create guild is false, user can review guild equal true, user can delete guild is true, and user can edit guild is false. So that looks good, but I want to understand the code that they're using to evaluate this. Oh, I see. User permissions, bitwise and can create guild. That's the 0b1000. If that's equal to the binary number can create guild, then we're good. But if the user permission doesn't have that, then it's going to be 0, and 0, it's not going to be equal to 10000. Okay. I see what's happening there. I feel like this could use extra explaining maybe for some of my viewers, so I'm going to take a screenshot of it and maybe work through an example. But let's just run again to make sure it looks good. The user can have the can review guild and can delete guild. Can review guild, can delete guild. Good. What's this? I'll look at that later. Not. We skipped a very important logical operator, not. The not operator reverses the result. It returns false if the input was true and vice versa. Print not true prints false. Print not false prints true. The operators and, or, and not are logical operators. Okay. On to chapter 4, which is comparisons. Comparison operators. When coding, it's necessary to be able to compare two values. Boolean logic is the name for these kinds of comparison operations that always result in true or false. So it looks like all of these are going to be either true or false. The operators, we have less than operator, greater than, less than or equal to, greater than or equal to, actual equal to, and not equal to. Assignment, change the operators in code, okay, confirm, so that each statement evaluates to true if it doesn't already. Change the operators, not change the numbers. So 5 less than 6, that'll be true. 5 not equal 6, that's good. Need to change this one to 5, and we need to change this one. So 5 equals 5 will be true. 6 greater than or equal 6 also will be true. Let's just submit this. Comparison operator evaluations. When a comparison happens, the result of the comparison is just a Boolean value. It's either true or false. Take the following two examples. Is bigger equal 5 greater than 4? Is bigger equal true? In both cases, we're creating a Boolean value called is bigger with a value of true. Since 5 greater than 4, is bigger is always assigned to the value of true. Why would I use comparison if I can just set it to true? Okay, that's a fair question. You wouldn't in this case. However, let's imagine that instead of hard coding the numbers 5 and 4, we want some dynamic variables that we don't know the values of. Perhaps you're making a video game and need to keep track of player scores. In order to calculate who wins, you would need to write something like this. Player 1 wins equals player 1 points greater than player 2 points. And we print player 1 wins. Let's see what this comment is about. Player 1 points and player 2 points are defined elsewhere and changed somewhere else in the game's code. Prints true when player 1 is winning, otherwise prints false. Okay, that all makes sense. Assignment. Use comparison operators to assign the correct Boolean values to the missing variables. Elon height 5, Sarah height 10, Jill height 7, Bob height 6. Don't edit above this line. Bob taller than Elon. I don't have to think about it. I just have to write Bob height greater than. Is there autocomplete here? No. Sarah taller than Elon is going to be true, but we're going to write it out. Sarah height greater than Elon height. And Jill taller than Sarah is going to be Jill height greater than Sarah height, which is going to be false. We have in here, oh, print, it's going to print the type of each one. Print type of that, print type of Sarah taller than Elon, print Sarah taller than Elon, print type of Jill taller than Sarah, and print Jill taller than Sarah. Okay, let's submit that. Very good. Comparison practice. Car size equal 4, truck size equals 5. Is smaller equal car size less than truck size. Is smaller is true. So again, we have this comparison operator, We compare two numbers and we get a result that's a Boolean value. Okay, on line 6, create a variable called enough armor and use a comparison operator to set it to true or false. So enough armor OR equals something comparison something. And set it to true or false depending on hero armor is greater than or equal to enemy damage. So the first something is hero armor. Hero armor is greater than or equal to. I feel like it shouldn't be equal to. Maybe it's okay. And your armor can withstand the enemies it blows is false. Okay. So again, the shape of that was enough armor equals variable comparison variable. Okay, on to the next. Increment, decrement. If we're changing a number and simply want to increment, add to, or decrement separate from these, there are special operators for those. What are the special operators? Oh, well, we've seen the increment and decrement operators. Plus, like the plus equals 1, or the minus equals 1, or the plus equals 2, minus equals 2. Notice that shield armor plus equals 1 is just shorthand for shield armor equals shield armor plus 1. Okay, decrement shield armor by 3 on line 7. Shield armor minus equals 3. Down to 2. Got it. If statements. So this is a good one because this is when we get into the value of a Boolean tells you whether or not some other code will execute. So let's see that in this course. It's often useful to only execute code if a certain condition is met. If condition, do some stuff here. For example, if Bob's score greater than Bill's score, print Bob wins. Take a look at the code. Edit player health on line 1 so that the code prints dead. Don't edit below this line. If it equals 0, prints dead. Okay, good. So again, let's look at the pattern here. We have if condition do stuff. But if condition is false, then we don't do that stuff. So I could write maybe do stuff. Okay, on to the next. If practice. If Bob's score greater than Bill's score, print Bob wins. Complete line 6. It should only log the warning message if number of swords is less than number of soldiers. So again, we're putting a condition here, and the condition is going to be variable comparison variable. We want to know if number of swords is less than number of soldiers. And we do not have enough swords for the army. Very good. If else, also elif. An if statement can be followed by 0 or more elif, which stands for else if statements, which can be followed by 0 or 1 else statements, which can be followed by 0 or 1 else statement. I guess that should be not plural. Huh. For example, if score greater to high score, print high score beat. Elif score greater than second highest score, print you got second place. Elif score less than third highest score, print you got third place. Else print better luck next time. So the pattern is if condition maybe do this. Elif condition maybe do this. I'll call this condition 1 and condition 2. If condition 3, maybe do this, then finally else do this. And the interesting thing here is that else doesn't contain a condition, because if these conditions haven't been met, this one's going to happen no matter what. So now talking about this code example, first the if statement is evaluated. If it is true, then the if statement's body is executed and all the other else's are ignored. That's what the if-else part means. If the first if is false and then the next elif is evaluated. Likewise, if it is true, then its body is executed and the rest are ignored. If none of the if statements evaluate to true, then the final else statement will be the only body executed. This just reminds me of Python for else. I'm not going to go into that right now, but I'm going to take a screenshot and talk about it later. Okay, assignment. Complete the code. It's missing some conditions. Let's reset the code. It should print dead if player health is 0. Otherwise, it should print injured if player health is less than 5. If neither of these are the case, it should print alive. Okay, so print dead if player health equals 0. So remember, it's variable comparison variable. If player health double equals 0, print dead. Else if a variable player health is less than 5, it should print injured, else it should print alive. Run that and we get injured. Note, for now the player health in the test code is always 4, so your output will always be injured. We'll learn how to write more dynamic programs in future assignments. Good to know. Did I remember to submit that one? I think I didn't. Okay, now we can go to the next one. If-else practice. Here are some basic rules with if-else blocks. You can't have an else, elif, or an else without an if. So you always have to have an if. You can have an else without an elif. Okay, that's that. Remember to check if two values are the same, use the equal operator. Same equal 5 equal 6, same is false. Same equals 6 equal 6. Notice the order of things happening here is that 6 equal 6 operates to true, and then true gets stored to same. Assignment. There's a bug in our code on line 6. So the bug is we left out our Boolean statement or condition. Edit the code so that if current player name is the same as high scoring player name, it logs you are the highest scores player. So variable comparison variable. Current player name is the same as equals high scoring player name. Print you are the highest scoring player, else print you are not the highest scoring player. As it happens, you are the highest scoring players, so let's submit that. Go on to the next one. If else practice. Same rules. 7 and 9 are missing their conditions, so we're going to fill it in with the same pattern. Variable comparison variable. We'll do the same thing on line 9. We want if current player name is the same, so equals as high scoring player name, so you are the highest scoring variable player. Otherwise, if current player name is the same as, so the comparison is equals, lowest scoring player name, you are the lowest scoring player. And that's the one that it evaluates to. Okay, very good. Let's now move on from that and head to a BRB screen. Loops. Loops are a programmer's best friend. Loops allow us to do the same operation multiple times without having to write it explicitly each time. For example, let's pretend I want to print the numbers 0 to 9. I could do this. Print 0, print 1, so on and so forth. Print 9. Even so, it would save me a lot of time typing to use a loop, especially if I wanted to do the same thing 1,000 or 1,000,000 times. A for loop in Python is written like this. For I in range 0, 10, print I. In English, the code says, in excruciating detail I might add, oh, hello, Sammy. Anyway, in English, the code says, start with I equals 0, I in range 0. If I is not less than 10, if I is not less than 10, exit the loop. We haven't seen a not less than. Well, we've seen less than. So we evaluate I less than 10, and then we flip it. Okay. Now print I to the console. Step 4, add 1 to I. Range defaults to incrementing by 1. Go back to step 2. The result is that the numbers 0 to 9 are logged to the console in order. White space matters in Python. The body of a for loop must be indented, otherwise you'll get a syntax error. Assignment. Complete the missing sections of the for loop so that it prints the numbers 0 to 99 to the console. So, we start with an I. The variable is going to be I, and it's going to be in a range object from 0 to 100. And I know it's 100 because when it's not less than 100, we will exit the loop. So at 99, we will print, but at 100, we will exit the loop and not print. You can see here 97, 98, 99. Submit. Complete 240 exercises. Wow. Complete. TV Josh says 10 million XP. Thank you, TV Josh. I appreciate that. So we've got some trouble with the diabetes stuff. I'm okay. Loops. As a reminder, a for loop in Python is written like this. For I in range 0 to 10, print I. In English, the code says start with I equals 0, I in range 0. If I is not less than 10, exit the loop. But if I is less than 10, enter the loop, print I to the console, add 1 to I, and go back to step 2. I feel like we could rearrange these instructions a little bit. Like, I think of it as if 1 start with I is 0, 2 check if I is less than 10, proceed into the loop. Let's exit the loop. Anyway, let's move on. The result is that the numbers 0 to 9 are logged. Okay, white space matters in Python. We've already gone through this. Write a for loop from scratch that logs the numbers 0 to 199 to the console. So we have for I in range, I in range. We start with 0. We write 200 because we want it to go to 199. We want to print I. Let's check that that runs. 199, yes. Submit. Loops practice. As a reminder, a for loop is written like this. Edit the for loop to print the numbers 5 to 15. I'm going to do what might be tempting and do range 5 to 15, and I'll run that. And oh no, it only printed up to 14. I guess I'd better type 16 so that it makes it to 15. Okay, let's submit that. That's good. I'll open the feedback survey in a new tab and maybe do it later. Loop review. For review, the loop for I in range 0 to 10, print I, prints the number 0, 9 to the console. Why should you want to use a loop? Because the computer understands loops better than repetitive code. Well, it understands both equally well, which is to say it understands nothing. So I won't answer that one. Let's get the timer back. Because loops speed up your app. Or because to do the same thing over and over again without writing the same code. That's the one I like. Okay, loop review. For I in range 0 to 1000 prints the numbers 0 to 999 to the console. Why does the code on the left print 0 to 99 and 0 to not 100? The choices include because print I only happens while I is greater than not equal to 1000. That's not it. Because print I only happens while I is less than not equal to 1000. That sounds right. While I is greater than or equal to, that's not right. Only happens while I is less than or equal to. That's not right. It's print I only happens while I is less than 1000. Okay, moving forward. Loop review. Whitespace matters in Python. The body of a for loop must be indented. Otherwise, you'll get a syntax error. And by the way, a lot of programming languages don't rely on whitespace to get the syntax right. Okay, not only that, but every line in the body of the loop must be indented in the same way. We use the 4 spaces convention. Pressing the tab key should automatically insert 4 spaces. Okay, it is blank to indent the body of a traditional for loop in Python. It is required. What is this fire thing? 1 days of study in a row. Huh. Range continued. The range function we've been using in our for loops actually has an optional third parameter, the step. For I in range 0 to 10, 2, print I, prints 0, 2, 4, 6, 8. The step parameter determines how much to increment I by each iteration of the loop. You can even go backwards, go by -1. In this case, it's smart enough to know that the number is greater than 0 for us to continue. Assignment. Fix the code so that it prints the numbers 10 to 1 in order. 10 to 0, -1. That should do it. Yeah, 10 to 1 in order. Submit. Hey, another million XP. Oh, I don't want to open Twitter right now. I'm glad that password was obfuscated. Okay, we did that. Move on to the next one with the bouncy blue arrow. F strings in Python. Oh, I like F strings. You can create a string with dynamic values by using F strings in Python. It's a really beautiful syntax that I wish more programming languages adopted. Number of bananas equals 10. F, quote, you have brace, num bananas, right brace, bananas. The opening quotes need to be preceded by an F, then any variables within curly braces have their values interpolated into the string. At the Hometown Tavern in Fantasy Quest, the innkeeper offers free meals and retirement plans based on the age of his patrons. I wrote a loop for you that increments the age variable from 0 to 76. In the body of the for loop, if age is less than 8, your code should print. Oh, we're gonna have to use things we learned in a previous lesson. if age less than 8, print f string quote. I'm used to seeing single quotes with an f string, but I'll follow their preference and use double quotes with the f string. You qualify for free meals. You are blank, and we'll replace blank by age, years old. Elif age greater than 65. Interestingly, not if age is equal to 65. You qualify for retirement. Print f quote. You qualify for retirement. You are blank years old. Age years old. So again, we put the braces and we put the variable name in here. And the syntax highlighting is nice because it suggests that this age is going to mean something different than if I typed age over here. Underscore should be the current value of the age variable, and we don't do anything, so I don't make an else statement. I could write an else statement, but the problem doesn't require it. So you qualify for retirement, you are 74 years old. Looks good. Sprinklers, not sprinklers. I don't know what to call those things, but I like them. Sum game. Remember that the increment and decrement operators can increment and decrement a variable by any amount. Number of enemies equals 10, number of enemies plus equal 2, so it'll be 12. Or number of enemies minus equal 2, so it'll be 8. Fix the bug in the program. Instead of adding 1 to total at each iteration of the loop, it should add I. For example, instead of 1 plus 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 1, okay, that's enough. We want 0 plus 1 plus 2 plus 3 plus 4 plus dot dot dot. TV Josh says, confetti. Yes, confetti is the right word. Okay, thank you. I needed some help with that one. We just want total plus equals I. And this should be some big number, 4950. That looks right. Congrats, you earned 189 XP. Sum game 2 assignment. Write a program that sums all the numbers from 0 to 99, but skips even numbers. So I'm starting thinking 0, 100. We could go by 2. This is going to be wrong. Let me just print I, not 8. Print I, and don't submit it yet, but run it. And notes that it's not skipping even numbers. Instead, it's doing only even numbers. How can we fix that? Well, we could start at 1 instead, and it'll continue while the number is less than 100. And now we get a different result. I don't want to print I for my submission, and submit. Hey, claim 500 XP. Continue. Okay, on to the next one. And I need to step aside because my dinner is about to come out of the oven. You know, I don't know why I'm wearing these. I don't need to be. There's no sound right now. Okay, getting back into it. Except the headphone cable is now in my way. Okay. Oh, we're on to another chapter. We are now going to study lists. A natural way to organize and store data is in the form of a list. Some languages call them arrays, but in Python we just call them lists. Think of all the apps you use and how many of the items in the app are organized in lists. For example, a Twitter feed is a list of posts. An online store is a list of products. The state of a chess game is a list of moves. This list is a list of things that are lists. Well, that got meta. Lists in Python are declared using square brackets with commas separating each item. Inventory equals iron breastplate, healing potion, leather scraps. Arrays can contain items of any data type. In our example above, we have a list of strings. Interestingly, this is kind of a we can also, if we wanted to, have different data types. I feel weird without the headphones on. I don't know why. Partly because I'm expecting to hear. I guess I want to hear the follow noises. So I guess I do want to hear if something happens in the headphones. Sorry, I'm losing focus here. Let's focus in. Assignment. Let's work on Fantasy Quest inventory. Take the 1 away. We can store items the player is carrying in a list. Add a short sword to the end of the list. So comma, and then quote for a new string, and short sword. And submit. Very good. List continued. Sometimes when we're manually creating lists, it can be hard to read if all the items are on the same line of code. We can declare the array using multiple lines if we want to. Keep in mind that this is just a styling change. The code will run correctly either way. Now you might be saying, but wait, Eric, I thought that indentation matters in Python. Well, the Python knows that when we're inside of, for example, what are these called? These are called brackets. I'm afraid I'm going to mess it up now. Square brackets. Yeah, that's right. So once we're within brackets, and it's the same thing for parentheses. If we're within parentheses, it ignores the leading white space. Okay, keep in mind this is just a styling change. When would you declare an array on multiple lines? When the array contains strings instead of numbers? Well, not necessarily. When there are only a few items, that doesn't make sense. When there are many items, and it's hard to read them all in one line. That's the one. Lists continued. Sometimes when we're manually creating lists, it can be hard. Oh, wait. Which types of items can be stored on a list? Is it numbers? Is it strings? Is it booleans? It is all of them. Counting in programming. In the world of programming, counting is a bit strange. We don't start counting at 1, we start at 0 instead. Indexes. Each item in the array has an index that refers to its spot in the array. Take the following array as an example. Names is Bob, Lane, Alice, Brianna. Index 0 equal Bob, index 1 is Lane, index 2 is Alice, index 3 is Brianna. Which index refers to the second item in a list? So first, second, goes 0, 1, or 0, 1. So the answer here is 1. I like to sometimes talk about, let's go to the next page so I can have something to work with. Indexing in lists, so good, we're still talking about that. First, second, third. Or we could talk about the 0 if, the 1 if, and the 3 if, 2 if. Let's justify these so they look better. Oh, I'm mixing this up terribly, but it'll be worth it for the point I'm making. This is more difficult than it needs to be. So 0, 1, 2, first, second, third, 0th, 1th, 2th, and that could go on. I like this way of counting when you're talking about zero indexed things. Okay, getting back to the course. Indexing with lists. Now that we know how to create new lists, we need to know how to access specified items in the list. We access items in a list directly by using their index. Indexes start at 0, the first item, and increment by 1 with each successive item. The syntax is as follows. So the syntax is to create a list. I'm going to do T for list, 1, 2, 3, and then access a value. And let's say access the 2th value. Which is actually the third value. And so it'll print 3. Yeah. 3 is the 2th one. Reset the code. Okay, indexing into lists. That's what we said. Print best language is 1. Print go because index was right. Well, that's very opinionated. Assignment. We need to allow our players to access items within their inventory. Change the value of item index to the index in inventory that holds the value of leather scraps. Item index. So item equals inventory at item index. We want leather scraps. 0, 1th, 2th, 3th, 4th. Where's leather scraps? Oh, leather scraps is here. It's the 1th one. So item index equals 1. Item leather scraps. Inventory. Index 1. Item leather scraps. Run. All right. The length of a list can be calculated using the length function, len. Again, we'll cover functions in more detail later, but this is the syntax. Length equals len of fruits. The length of this list is equal to the number of items in the list, the number of items present. Don't be fooled by the fact that the length is not equal to the index of the last element. In fact, it will always be greater by 1. Why is that the case? Well, we have t equals 0, 1, 2, and we are counting 1, 2, 3. Then length of t is going to be 3. It's because we index from 0. So the last index is 1 less than the length. And that's always going to be the case in a Python list. Assignment. Some of our players' inventories are huge, so looking through the entire list is cumbersome. Let's make an easy way for them to see the last item in their list. Set the last index variable equal to the length of inventory minus 1. You will need to use the len syntax. Last item, iron bar. Let's see that that's right. Oh my, there are so many items in there, but iron bar is in fact the last one. Okay, submit. List updates. We can also change the item that exists at a given index. For example, we can change leather to leather armor in the inventory array in the following way. Inventory equals leather, healing potion, iron ore. Inventory 0 equals leather armor. Now inventory equals leather armor, healing potion, iron ore. So we have this my list at index equals new value. And it's like we're assigning the new value to my list at this index. The assignment is we need to update the items in our player's inventory when they smelt iron ore into an iron bar. On line 6, reset the code. Update the iron ore element in the array to be an iron bar. Iron ore is at index 1, the 0th, 1th. So inventory at 1 equals, quote, iron bar. Run this code. We have healing potion, iron bar, bread, short sword. Looks good. I really don't want to get one of these wrong. I've got such a streak going that I'm almost afraid to mess up. It's common to create an empty list, then fill it with values using a loop. We can add values to the end of a list using the .append method. Cards equals empty list. This is a common pattern in a for loop, and actually I see here that we are using the for loop over there. So that's good. Cards.append NVIDIA, cards.append AMD. The list of cards is now NVIDIA and AMD. Assignment. We need to generate a unique user ID for each player in the game. An ID is just a unique number. Use a loop to add the IDs of 0 through 99 to the player IDs list. I will say, yes, integers are unique and they're easy to come up with, but they're not always the best IDs that you can use. There are other ways to generate IDs that are more cool. But this is going to work for now. Player IDs dot append, and we just append I. Use a loop to add the unique IDs of 0 through 99 to the player IDs list. Print player IDs, and sure enough, we have, let's check that it starts with 0 through 99. Okay, submit. Pop values. .pop is the opposite of .append. Pop removes the last element from the array and returns it for use. For example, so p equals 1, 2, 3. That's an example. Last int equals p.pop. And now last int equals 3, but what does t equal? T equals 1, comma 2. Assignment, our player is selling items in their inventory to the shopkeep. Pop, let's reset the code. Pop the last item from inventory. Don't touch above this line. Don't touch below this line. For I in range 0 to length inventory. Pop the last item from the inventory list until there is nothing left. Pop the items into an item variable so that it prints each time on line 17. Okay. Item equals inventory.pop. Interestingly, we don't seem to be using I at all, which some IDEs, an IDE is an integrated development environment. Some IDEs would complain about that, but for now we're okay. Okay, so we come down, we sell the healing potion because it was the first thing, so it's the last thing to get popped, and then the inventory is empty and we're good to go. Counting the items in a list. Remember that we can iterate count over all the items in an array using a loop. For example, the following code will print each item in the sports array. For I in range 0, comma length of sports, print sports I. Assignment. Our players need a way to see how many copies of a specific item they have in their inventory. Within the loop, count how many times potion, bread, and short sword appear in using the potion count, bread count, and short sword count variables respectively. So I'm going to solve this using what we've learned already, which is if statements. So if, remember, variable, comparison, variable, then we'll do something. So if items at I, and the comparison is equals potion, but I'll do it with double quotes because that's what they have been saying to do. Potion count plus equals 1. Elif. We can use an elif statement here. We could also just write if, but let's use elif. If items I equals bread, then bread count plus equals 1. Elif items I equals short sword, then short sword count plus equals 1. And now let's run this and see what the counts all are. It says you have 4 potions, 6 pieces of bread, 3 short swords. I don't feel like counting them, so let's just say that this is good. And it is. Excellent. Moving onwards. No index syntax. In my opinion, Python has the most elegant syntax for iterating directly over the items in a list without worrying about index numbers. If you don't need the index number, you can use the following syntax. I was actually going to maybe think about mentioning that, but it looks like the course has done it for us. So trees equal oak, pine, maple. For tree in trees, print tree. And it prints oak, pine, maple. Tree, the variable designed using the in keyword, directly accesses the value in the array rather than the index of the value. If we don't need to update the item and only need to access its value, then this is a more clean way to write the code. When should we use the no index syntax? When we don't need to know the index, just the value, that's a good time. When we need our code to be faster, I don't think it really changes how fast the code goes, because it's all C under the hood, right? And C is going to be doing indexes. Or when we want to write code that is harder to read, and that's not a good reason. Okay, 12, no indent syntax. More on this. Which method of writing for loops is considered more clean, assuming both options will work? Definitely for item and items is more clean to write and read. Find an item in a list. Example of a no index or no range syntax. For fruit and fruits, print fruit. Assignment is we need to check if a player has a specific item in their inventory. Use the no index syntax. So we're going to say for item in inventory. To iterate over each item in the player's inventory, if you find an item called leather scraps, set the found variable to true. If you find an item, so if item equals leather scraps with double quotes, because that's the way they said they like it, found equal true. And are we going to find it? Leather scraps. Yes, we are. Found the leather scraps. Very good. Next. 14, find the difference. Assignment. We keep track of a character's level in an array. When someone's level changes, we want to know about it so we can congratulate them. Find any differences between old character levels and new character levels, and when you find them, print the index where the levels are different. Don't touch above this line. So now we have iterate, loop over both arrays at the same time using the range syntax and print the indexes where the items in the arrays differ. For example, if the arrays were 2 and 2, 5 and 5, 3 and 19, that's a big level up. 7 and 7, 5 and 8, your code should print 2 and 4 because 0th, 1th, 2th is different, 3th, 4th is different. Okay. Hey, 5 viewers. How about that? Thanks for stopping by. If old, let's copy paste it. If old copy character levels is not equal to, oops, we need it at I, not equal to new character levels at I, we'll do something. I think they just wanted us to print the index. Print I. Oh, we've got lots of indices to potentially print. 14, some other ones. Got it. Modulus operator in Python. The modulus operator can be used to find a remainder. For example, 7 modulo 2 would be 1 because 2 can be multiplied evenly into 7 at most 3 times. 2 times 3 equals 6. Then there is 1 remaining to get from 6 to 7. The modulus operator is the percent sign, percent. It's important to recognize modulo is not a percentage though, it's just the symbol we're using. Modulo 8, 3, twice 3 gets you to 6, and there are 2 more left, so the remainder is 2. An odd number is a number that when divided by 2, the remainder is not 0. So assignment, create an array of the odd numbers between 0 and 299 inclusive. Well, we already have I'm deciding which way to do this. I could start at 1 and go by 2, but I'm going to not do it that way. I'm instead going to use what we just learned and say if I modulo 2 not equals 0. And for clarity, maybe I'll add a parentheses here. Then odd numbers, oops. I wrote a 3 where I should have written a 2. Numbers dot append I. And let's see if that looks right. Up to 299, starting from 1. Okay, let's submit that and see if we got it. Yes, we did. Yay, confetti. Thank you, TV Josh, for shouting out that for shouting out that it's confetti, that it's flying at me. Slicing lists. Python makes it easy to slice and dice lists to work only with the section you care about. One way to do this is to use the simple slicing operating, which is just a colon. With this operator, you can specify where to start and end the slice and how to step through the original list slicing through the original. List slicing returns a new list from the existing list. The syntax is as follows. LST, initial, and index jump. That you might recognize from range, where it was initial and jump. So like 1, 100 by 2. So it gives you all the odd numbers. Reset code. The above reads, give me a slice of scores list from index 1 up to but not including 5, skipping every second value. All of the sections are optional. If they're optional, how does it know which one you mean if you only put in 2? So 1 through 5 gives you 70, 30, 20, 90. And 1 through all gives you 70, 30, 20, 90, 10, 50. Okay. First, assignment. First, print a slice of champions list that starts with the third item in the list. 1, 2, 3. So that's the 2th item. First, print champions sliced starting from the third, which is index 2, and take all the rest. Then print champions starting at print a slice of the champions list that ends with the third item from the end of the list. I happen to know that I could use a minus, but I'm not going to do that. I'm going to just count 0, 1, 2, 3, 4, 5, 6. It would be the 7 if we wanted them all, but 1, 2, 3, 7, 6, 5, 4. I think that's the way to do it. And thirdly, print champions that skips every odd number index. All of them by 2. So how does it know the difference between what I'm asking for? I think I need double colons here. So champions 2 through all, 0, 1, 2 to the rest of them. I think I got this right. Yes. Oh, it paused for a second and I thought maybe I missed it. That's funny. List operations, concatenate. Concatenating 2 lists, smushing them together, smush, is really easy in Python. Just use the plus operator. Print all, so all is 1, 2, 3 plus 4, 5, 6. Print 1, 2, 3, 4, 5, 6. Assignment. Fantasy Quest allows users to keep lists of their favorite items. We need to add them all to one giant list so we can keep track of the totals. John's favorite, Jack's favorites, Brianna's favorites. Don't touch above this line. Create a new list that has John's favorites, followed by Jack's, followed by Brianna's. So new, I'll just call it new, equals and I'm going to copy paste as John's favorites, followed by Jack's favorites, followed by Brianna's favorites. Yeah. Print length of new, and print the actual list containing all the items. Print new. So we've got a total of 6. That makes sense, and we've got all the items, so let's submit. List of operations contains. Checking whether a value exists in a list is also really easy in Python. Just use the in keyword. So fruits equals apples, orange, and banana. Print banana in fruits. The result is true. Tip, quotes within quotes. In order to use quotes within quotes, you either needs to be escaped or you need to use the other kind of quotes. Because we usually use double quotes, we can nest strings within single quotes. F, double quote, banana is in fruits lists. Brace, single quote, banana in fruits. That's interesting. Assignment. Our players have requested an in-game feature that will allow them to type in a weapon name to check if it's in the list of top weapons of the realm. So we have a list of the top weapons. Don't touch above this line. Take a look at the top 3, at the 3 print statements. Replace the static Boolean values in the curly brace with an in statement that checks if the weapon in the text is in the top weapons list. So we're checking if, let's give ourselves some more space here. We're checking if Sword of Justice in, what's the list called? Top weapons. Next, we check if Great Axe in top weapons, and then Killer Bow in top weapons. How come I can't? I want to. I think I messed up the. I'm trying to scroll the thing back up so we can see things. Might have to refresh the page. Is this gonna, oh, it remembered my stuff. That's nice. And now we can, Sword of Justice is a top weapon, true. Great Axe is a top weapon, true. Killer Bow is a top weapon, false. Run. Oh, we already ran it. Let's submit it. Yeah. List deletion. Python has a built-in del keyword del that deletes items from objects. In the case of a list, you can delete specific indexes or entire slices. So nums equals 1, 2, 3. This is tricky. Del nums 3 deletes the 4th item, or if you will, the 3th index item. So the output is 1, 2, 3, 5, 6, 7, 8. Delete items from the 2nd to the 3rd, or from the 1th to the 3th exclusive. So we're left with 1, 4, 5, 6. Delete all elements. Del nums colon. Print nums output is none, or is empty list, which is different from none, importantly. Assignment. In Fantasy Quest, there are a list of strongholds on the map that players can visit to defeat powerful bosses. First, delete the first stronghold from the list. Del strongholds at the 0th position, which is the first. Print the list of strongholds. Print strongholds. Delete the last 2 strongholds from the list as a slice. Del. They didn't tell us this, but I know that we can do -2 all like that. I don't feel like counting how many there are. Print the list of strongholds. That leaves us with the Morgoth Mountains, the Lonely Island, Mordia, and oh, that's wrong. Okay, fine, I'll do the counting. Or is it wrong? I'm getting hungry. Morgoth Mountains, the Lonely Island, Mordia, Mordain, Gondolin. We're left with minus. Delete the last two strongest from the list as a slice. So get rid of Mordain and Gondolin. That's not right. I want from -2 to the end. We have Mordia. Okay, that's good. Ooh, okay. Was getting a little scared there. That's it for lists. Chapter 7, Functions. Functions allow us to reuse and organize code. For example, let's pretend we need to calculate the area of a circle. We can use the formula area equals pi times r squared, or in code, r equals 5, area equals 3.14 times r. This works great. The problem arises when there are multiple places in our code that need to get the area of a circle. So this example is going to show repeating code. R equals 5, area equals the formula. R2 equals 7, area 2 equals the formula times R2. R3 equals 11, area 3 equals the formula with R3. R3 times R3 because it's squared. We want to use the same code. Why repeat the work? Let's declare a new function, area of circle. Notice that the def keyword is written before the function name and tells the computer that we're declaring or defining a new function. The area of circle function takes one input, which can also be called a parameter or argument, and returns a single output. We give our function the radius of a circle and we get back the area of a circle. To use, there's looks like a typo in here. Let me take a screen cap of that. To use or call the function, we can pass in any number as the input and capture the output in a new variable. Radius equals 5, and area of circle equals area of circle parens radius. Let's talk through the code by step. And I'm going to write an example over here for further discussion. Oh, meow, Sammy. Meow. Hello. Okay. So the radius variable is created with a value of 5, or here I created the length with 5. Let's make it 6 so it's different. The area of circle function is called with a single argument, radius, or here I take area of rectangle with a argument of length. The area of circle function is executed with r being equal to 5. And then we have to scroll up to see what was in that function. And I have to define area of rectangle of L. L maybe isn't a great variable to use because sometimes L looks like 1, but we'll go with it. The result of 3.14 times r is returned from area of circle, which happens to be 78.75, or here it would be 36. I'm going to print it to prove that I have the right idea there. Okay, area of circle radius resolves to the return value of 78.75, or in this case, 36. And the area variable is created with a value of 78.75, or in our case, 36. Let's run this to, what did I do? Area of rectangle typo. See, it says name error, name area of rectangle is not defined. 36. So there we have that. Assignment. Let's reset the code, confirm. We need to calculate the area around a player that they're able to attack with. Attack within. With a 1 meter sword, for example, they should only be able to attack enemies within the area of a circle of 1 meter radius. On line 8, add a second function call to area of circle that passes 0.5 in as the radius. Capture the result in a new variable called player2 area. Okay, so we're gonna have player2 area is equal to area of circle with 0.5. And we'll submit that. Very good. So to review on that, we had area of circle, which is a function, and to call that function, we write it with parentheses around whatever the input or argument to the function will be. Oh, hello, Sammy. Are you here to interrupt me? Do you want some attention? I know you can't see him, but he's here. Just being a kitty. All right, Sammy, you get to be on camera now. There he is. And there he goes. Oh, Sammy. That's what you get when you come up on my desk. You get thrown off to the internet. Let's move forward. Multiple parameters. Functions can have multiple parameters or inputs. We can have define subtract of a and b, return a minus b. Assignment. We need to calculate the total damage from an attack involving 3 different enemies. Complete the calculate damage function that takes 3 numbers in as its parameters and returns the result. I'm going to screen cap because that's missing a word. Complete the calculate damage function that takes 3 numbers as its parameters and returns the result of adding them all together. So return, the inputs are enemy 1 damage plus, well, we have negative damage down there. That's interesting. Plus enemy 2 damage. Whoa, what did I do? I guess I can have multiple. I can write on multiple lines. That's what I did. That's interesting. Okay. What did I do wrong though? Oh, we don't need a plus sign here. That's not right. You dealt 6, not points, 9 points, 6 points, 9 points, 7 points. Okay, looks good. So what did we do there? Let's review that. We have a function definition, which they gave us these inputs, and we said that the result of the function will be to return the sum of those inputs. Where to declare functions? You probably noticed that a variable needs to be declared before it's used. Let's show an example of that. A equals 5, print A. This is going to work just fine. But if we reverse that and try to print A before we define it, what? Oh, that's interesting. So let me review what happened here. I said A equals 5, print A, and let's run it. It does fine. That's not surprising. So let me screen cap that for later. But now let's say A equals 7, but we try to print it. before we set it, and it gets a is 5. What if we run it again? Then it gets a is 7. Let me take a screen cap of this. This feels like a bug to me. Take a screen cap of this, run it again, and it gets 8. So the environment remembers what the previous value of a was. That's an interesting behavior. Let's refresh the page so that we start with a fresh thing. Let's print b and say b equals 7. The first time we run this, we get name error, b is not defined. That's as expected. But if we run it again, wait, now it works. Oh, we never defined b. But now if we run b equals 7, okay, that's fine. And then print b, it's going to say 7. Because it remembers how we defined b before. That is so weird. Okay, let's reset the code and get back to where we were. Where to declare functions. You probably noticed that a variable needs to be declared before it's used. That was what that whole playing was about. For example, the following doesn't work. Print my name equals Lane Wagner. It needs to be my name equals Lane Wagner, print my name. Lines of code execute in order from top to bottom, so a variable needs to be created before it can be used. That means that if you define a function, you can't call that function until after the definition. The main function is a convention used in many programming languages to specify the entry point of an application. By defining a single main function and only calling main at the end of our entire program, we ensure that our function are defined before they're called. I should take a screenshot of the whole thing. There's a bug in a program, fix it. Yeah, the bug is that main has to be called after it was defined. Fantasy Quest is booting up. Okay, there we have that. Although, interestingly now, if I screen cap this, I'm going kind of wild with the screen caps, but that's okay. And if I put it back to that way, then it succeeds where it probably shouldn't. Will I report an issue now? I don't want to figure out how to do that. I'll do that later. Let's go back to the correct way so I can submit this. Okay, got through that one. Took me a while because I went on some detours, but that's okay. Order of functions. All functions must be defined before they're used. You might think this would make structuring Python code difficult because the order in which the functions are declared can quickly become so dependent on each other that writing almost anything becomes impossible. As it turns out, most Python developers solve this problem by simply defining all the functions first, then finally calling the entry point function last. If you do that, the order of all the functions are declared in doesn't matter. The entry point function is usually called main. Let's play around with this example on the previous page. This is kind of an interesting example. So clearly this works. Let's actually refresh the page just to prove that it's not remembering something from before. So we define function main, and we say that main contains function 2. That's okay because we're not trying to run function 2 yet. We're not trying to execute function 2. We can define function 2 later. and Python will know that function 2 is going to call function 3, but it doesn't care yet what function 3 is because it hasn't been executed. Then we define function 3, and to print I am function 3. And only once we run main does the cascade of main calls function 2 and function 2 calls function 3 and function 2 calls function 3, or something like that. I think I overstated one of those. That's the point of that example. Okay, functions must be defined before they can be called. Yes. However, they can be defined in another function before they've been defined them. They can be used in another function before they're defined themselves, provided that they get defined before we try to run them. Does that make sense? I mean, I don't know one's here. I don't know one's answering in the chat right now, but just rhetorically, does that make sense? True functions must be defined before they can be called. And the next question is function says Python functions must be defined in the order they call one another. That one is false. We saw it down here. Like, if that were true, I'm not sure I love the wording on this one. Let me take a screenshot to remind myself of that. I mean, that's false. They can be defined in any order as long as they've all been defined by the time we need to run them. That's what matters. I think I'll make a separate video about that detail. That's a good detail. Scope. Scope refers to where a variable or function is available to be used. For example, when we create variables in a function by giving names to our parameters, for example, that data is not available outside of the function. For example, define subtract of x and y, return x minus y, result equals subtract 5, 3, print x. Error, x is not defined. Let's prove to ourselves that that's actually what happens. I mean, I know it is, but let's prove it. Invalid syntax. Ha ha, it's missing a colon. That's hilarious. Now what? Name x is not defined. Okay, hold on. Let me run this code. And take this one. Okay, when the subtract function is called, we assign the variable x to 5, but x only exists within the subtract function. In other words, it's a local variable. If we try to print x outside of that function, then we won't get a result. In fact, we'll get a big fat error. Assignment, find the bug in the code. We're using variable names from the wrong scope. Fix it. I need to reset the code. Don't touch above this line. Wait, what's going on here? Oh, okay. See, it's calling get max health as a function of modifier, but modifier is not defined in the main scope. In fact, if we run this, we should get error, name modifier is not defined. So we have to give it my modifier and my level. And now it should run nicely. Max health is 50. Okay, good. That works. Type error failed to fetch. That's weird. Okay, got it right. I don't know what happened. I don't know what happened. Global scope. So far, we've been working in the global scope. That means when we define a variable or a function, that name is accessible in every other place in our program, even within other functions. So for example, if pi equals 3.14 and define get area of circle radius, return pi times radius, pi is available from the global scope, while radius is available in the local scope. Because pi was declared in the parent global scope, it is usable within the get area of circle function. Assignment. Let's change how we are calculating our player's stats. The only thing we should need to define globally is the character level, and then let our functions do the rest. I'm not sure I love declaring character variable globally, but I'd have to think about like the implementation details before I would be sure of that. Okay. Declare player level at the top global scope and set it to 4. Let's see what this is doing. Character has 15 primary stats. Character has 40 max health. So we're using player level along with the local variables, which are the arguments, to calculate things. Scope quiz. Can functions access variables declared outside in the global scope? Yes, they can. Scope quiz. Can code outside the scope of a function access variables that are inside of that function? No, they cannot. Functions practice degrees. Conversion formula, Celsius equals 5/9 times Fahrenheit minus 32. Okay. Assignment, let's take a break from working on Fantasy Quest for a moment. Instead, we will use what we've learned to build a function we could use in the real world. Write a function called toCelsius that converts the temperature in Fahrenheit to Celsius. Okay, we're practicing writing function. I'll go ahead and say that Celsius equals, I'll make it simple by copying. I can't type Fahrenheit because they gave us F. So just F minus 32. And for consistency, let's call this C. 112 degrees is 44.44 degrees Celsius. That sounds about right. Notice something that is here. I made a variable C and then returned C, but we can actually save some writing by just directly returning the result of that calculation. And that's going to give the same answer, 44.44 degrees Celsius. Looks good. Another functions practice exercise. Let's get back to working on Fantasy Quest. We need to make a way to easily check if an item exists within our inventory. Complete the string exists function that checks if a given string can be found within an array. This is a pretty basic function to have to write, but okay. String exists Sally and Bob, Joe, and Bill is false. String exists Sally and Bob, Sally, Bill returns true. So we just have to write string return string to check in string array. I think that's what they called it. Yeah, that's right. Healing potion does not exist in this list. Iron helmet does not exist in this list. Iron ore exists in this list. Short sword exists in this list. That all looks right. Boolean logic. I think we talked about Boolean logic before. Boolean logic refers to dealing with Boolean true or false values. For example, dogs must have 4 legs and weigh less than 100 kilograms. Both conditions must be true. Cats are cool if they go faster than 200 miles per hour or if they are electric. Oh, cars. Huh. I'm thinking about cats, obviously. At least one condition must be true. And syntax. The AND operator. Maybe we haven't seen the AND operator before. The AND operator takes a Boolean value on each side and returns true if both Boolean values are true. Let's go over how this function would evaluate given the parameters 4 and 99. Return true and true, return true. Let's see what happens with what happened with 3 and 98 instead. Return 3 equals 4 is false. 98 less than 100 is true. Return false. The AND operator will only return true if both conditions are true. Or syntax. The OR operator returns true if at least one of the conditions are true. Def is cool car of speed and is electric, returns speed greater than 200 or is electric. Let's use a non-electric car that can do 250, return 250 greater than 200 or false. This is odd to me. I'm gonna take a screen cap. I don't know why we're suddenly back on Boolean logic in the middle of functions. Return true. Assignment. We need a way for our game to track whether our character's attack hits or misses. Complete the does attack hit function. The following should return true if either of the conditions are met. The attack roll is not a 1. So condition or condition. First condition is attack roll not equal 1. Oh, it's if either of the following conditions are met. So either condition and condition or condition. That's the shape of it. So the attack roll is not a 1. That's the first condition. And the attack roll is greater than or equal to armor class. Or the second condition is attack roll equal 20. What did I do wrong here? Invalid syntax. Oh, single equal. That's an assignment operator. That's a mistake. I should have written double equals for the equality comparison operator. With a roll of 17 and an armor class of, I don't feel like going through all of these. Let's just submit it. Good. And let's review what I put in here. We have a condition and a condition combined with an and. That becomes one condition. And then we have condition or condition. Boolean quiz. Refer to the following Boolean statement. What is the value of result? Is tall equal true? Is fat equal true? Is skinny equals false? Is short equals false? Result equals is tall and is fat, or is skinny and is short. True and true is true. So we have true or something, but with an or, if either one is true, then the result is true. So the answer is true. That's an example of short circuit evaluation. I don't need to care about the result of the second half because I already have a true, and that makes the or, that satisfies the or regardless of what the second half is going to be. Hours to seconds. Assignment. We need to display the current in-game time in seconds to our players. Write the convert hours to seconds function. It should convert hours to seconds. So how do we convert hours to seconds? We take hours, we take it times 60, we get minutes, we take it times 60 again, we get seconds. And we need to remember to return the result of that calculation. 33 hours is 11,8800 seconds. I'll take that on faith. It says it's correct, so we'll go with it. First element from array, assignment. Let's add another function to our inventory system. Write a function that returns the first element from an array. If the array is empty, then return the string error instead. We haven't learned try catch yet, so I'll use if statements. If length of items equals 0, return error, else return items 0. So remember, the way to access an item from a list or an element from a list is to use the square bracket and then give the number of the index. First item in blank is error. First item in this is iron ore. First item in 1, 2 is 1. Okay, those all look good. Should serve drinks. Assignment. In Fantasy Quest, players can go to a town's local pub. Drinking virtual beer refills their stamina. Complete the function that determines if a bartender should serve drinks to a customer. The function should return true only if all of the following conditions are met. So we have 3 conditions. I'm going to write condition and condition and condition just to organize it. Return and I'll put parentheses around these conditions because it'll help me keep track of things. So the first condition is the time is between 5 and 10 inclusive. Where is the time? Here's the time variable. So 5 less than or equal to time, and time less than or equal to 10. The bartender is not on break. We have an on break variable, so oops. And not on break. And condition. What is this variable called? And customer age greater than or equal to 21. Let's test this. Age is 22, on break is false, time is 8, should serve equals true. When time is 1, should serve as false. When on break is true, should serve as false. When age is 18, should serve as false. And in the last cases, everything's okay, so it should serve as true. Time is 11, should serve as false. That all looks good. Hey, scholar, cool. Find max, infinity. The built-in float function can be used to create a numeric floating point value that represents a negative infinity value. I've added it for you as a starting point. Negative infinity equals float minus inf. Positive infinity equals float inf. Assignment. Our players want to find a way to see if their strongest attack from their last combat. Let's add another function to analyze data from our combat log. Complete the find max function so that it looks at each number in a list and returns the maximum value. If no maximum found, it just returns negative infinity. How can it not manage to find a maximum? Oh, if it's an empty list, then it won't find a maximum. So for num in nums, if num is greater than the maximum, if num is greater than the max so far, max so far equals number. See if these check out. Max of 1, 2, 3, 4, 5 is 5. Max of these is 300. Max of these is 20. Max of these is 5. Max of these is 21, max of these is minus infinity. Maybe it's worth me talking a little bit about why we need to use infinity here. We need something to compare the first number to, and we want it to be the smallest possible number because then num will always be greater than that. If we, just for an example, if we started with max so far equals 0 and we run that, well, we get the right answer for all of these. But if we had something that was all negative numbers, then this program, as it's currently written, would return 0, which is not correct. That's why we need the float minus infinity value. Although I will point out there's another way to do this, which is to write max so far equals num 0. And that also, oh, that doesn't work. Haha, because there's an empty list here. Okay, forget about that example. That was a bad example here. If I was going to do it that way, I would have to write a check to see that the numbers list is not empty. Okay, let's submit this. Reverse array. Assignment. Some of our players would like to view their inventories in reverse order. Let's write a function that takes an input array and returns a new array except all the items are in reverse order. Goes like that. I can think of two ways to do this. The first and simplest to write is just to return items with slice notation, all minus 1. And we have learned about slice notation in this course, so I think that's fair. Now order reverse in is array this. That's cute. The other way I could potentially do this would be for I in range length of items. Or let's do length of items, comma 0, comma minus 1. Output equals empty list. Output dot append items I. Return output. Let's check that that looks good too. It does not look good. Oh, that's interesting. What did I do wrong? Oh, it's inclusive at length of items. We need length of items minus 1. And we need minus 1, so it'll go down to 0. That's a little tricky. But it works. I'm going to go back to the simpler approach. Got it. And I like the confetti. Functions quiz. Which keyword is used to create functions in Python? That is def. None return. When no value is specified for a function, for example, maybe it's a function that prints some text to the console but doesn't explicitly return a value, it will return none. The following code snippets all return exactly the same thing. So return none, return without saying anything, or not even including a return keyword. What happens if there is no return line in a function? The program crashes. No, it's not that. It just returns none. Parameters versus arguments. Parameters are the name used for inputs when defining a function. Arguments are the names of the inputs supplied when a function is called. To reiterate, arguments are the actual values that go into the function, say 42.0, the dark night, or true. Parameters are the names we use in the function definition to refer to those values, which at the time of writing the function could be anything. That said, it is important to understand that this is all semantics, and frankly, developers are lazy with these definitions. You'll often hear the words arguments and parameters used interchangeably. But to be pedantic, A and B are parameters, 5 and 6 are arguments. And blank are values that are passed into the function by the caller. We have arguments. Blank are inputs specified by the function definition, parameters. All right, one more in this section. Multiple return values. In Python, we can return multiple return values from a function. All we need to do is separate each value by a comma. Return get user return name at domain.com 21 active. Email, comma, age, comma, status equals get user, print email, print age, print status. There's kind of a lot going on within this code, but let's see what else the course says first. Oh, this is weird. Email underscore underscore equals get user. It says this works, and by convention, you should not use the underscore variable later. I don't know why they're showing an example where they use the underscore variable then. And it's interesting that 21 gets thrown out. So the last time I guess that makes sense because that's essentially saying like email equals get user, the 0th one, underscore equals get user, the 1th one, and underscore equals get user, the 2th one. Assignment. We need to filter the profanity out of our game's live chat feature. Complete the filter message function. It takes a list of chat messages as input and returns 2 new lists. The first list contains the same message, but with all the instances of the words shoot and dang removed. The second list contains the number of shoot and dang words that were removed from the message at that particular instance. It looks like we have some helpful instructions for this. Clean messages equals empty list, and create 2 empty lists that you'll return at the end of the function. Clean messages is that number of dirty word counts. Call it that. Sometimes naming things is the hardest thing in programming. For each message, so I'm thinking for loop, for message in messages, split the message on white space using the split method to get a list of words. So my list equals, I'm not going to say list because that's a special word in Python. So my list, otherwise I could just say P, or I could call it words equals message dot split on the space character. I don't know why I tried to write a colon there. Good words is empty list. Create a new list that will contain all the non-bad words for this message. 3, create a counter variable and set it to 0. We'll increment this when we remove words from the message. For each word in the message, for word in words, if word is in the list dang or is in the list dang or shoot, counter plus equals, increment the counter plus equals 1. Else, if it isn't a bad word, instead add the word to the non-bad word list you created. Else good words dot append word. 5, join the list of bad words into a single string. I'll just write a comment for that now. Join good words into a string. 6, append the new clean message to the final list of filtered messages. Clean messages dot append my string. Append the counter of bad words. Am I getting my indentation correct here? I might not be. For message and messages, so we're still in the for message and messages loop. Is where we want to be. Clean messages dot append my string. Dirty word counts dot append counter. Return the messages first. Now we should be at this indentation, the indentation that's within the function, and we return clean messages, comma, dirty word counts. Let's try running that. Oh, made a mistake. My string is not defined. That's right. That's because I haven't done that yet. The join and split tips, joining and splitting strings in Python. I already did the split, but join method, the syntax here is we choose the string for joining, and then we give it dot join and the list, hello there, Sam. So I guess I'm calling it my string. Let's call it S. No, let's call it clean which equals space dot join good words. Clean messages dot append removed one words, censored text, well, it. That doesn't make a lot of sense. Remove 2 words, censored text, and pain and the whole thing. What does that come from? Shoot and pain and the whole dang thing. Fun. All right, I'll review the code that I wrote. We start a clean messages list. What are we going to do with that? We're going to take clean messages and append clean message. Clean message came from joining the good words, and the good words came from checking whether word is in the bad list. Meanwhile, dirty word counts. We take dirty words counts and we append counter. Where did counter come from? Counter came from here if word was in the bad list. And this code looked all right. I mean, these results looked all right, so let's submit. Very good. Okay, we're almost done with the chapter 7 functions chapter. Default values for arguments in Python. Python has a way to specify a default value for function arguments. This can be convenient if a function has arguments that are essentially optional, and you as the function creator want to use a specific default value in case the caller doesn't provide one. A default value is created by using the assignment operator in the function signature. So define greeting email, define get greeting of email comma name equals there. That's clever. So it says hello name. It would say hello there, or else it would say hello Lane or whatever. So message equals msg equals get greeting, Lane at example.com, Lane. Hello Lane, welcome. You've registered your email, Lane at example.com. message greeting, hello there, message get greeting of lane@example.com, hello there, welcome, you've registered your email, lane@example.com. If the second parameter is omitted, the default value there value will be used in its place. As you may have guessed, in order for this structure to work, optional arguments that have default specified come after all the required arguments. Assignment. We need to write a calculate damage function that accepts a weapon name and an armor value as inputs and returns the correct amount of damage to be inflicted as an attack. The thing is, a weapon is actually optional. If no weapon is specified by the caller of the calculate damage function, we'll just assume the attacker is using the fist weapon. I get it, weapon equals fist. Return the attack damage minus armor value. See the attack values of the various weapons. Anything else just return 0 as the total damage. I'm tempted to write a dictionary, but we haven't learned dictionaries yet, so I'll just write this with if statements. So we have attack. We don't have to define attack damage yet. If weapon equals fist, attack damage equals 5. Elif weapon equals... This logic is going to be a little bit twisted, but it'll work. Elif weapon equals dagger. Attack damage equals 10. Elif weapon equals sword. Attack damage equals 15. Else just return 0. But if we have any one of those, then we return attack damage minus armor. First, just check that it runs. Hit by a spell. Hit by a fist, 3 damage with 2 armor. Hit by a dagger with 3 armor, 7 damage. That looks right. Hit by a dagger with 2 armor, 8 damage. Hit by a sword with 5 armor, 10 damage. Those all look correct. Yay, confetti. And now we learn about dictionaries. That's funny that I wanted it in the previous one. Dictionaries in Python are used to store data values in key value pairs. Dictionaries are a great way to store groups of information. Car, brand is Tesla, model is 3, year is 2019. Assignment. Complete the get character record function. It takes a character's name, server, level, and the rank. It should return a dictionary with 5 values. So return, we have this dictionary. Name is name from the function. Server is server from the function. Level, oops, double quotes because that's what they like us to use here, is level from the function. Rank is rank from the function. And ID is ID from the function. Oh, interesting. Are they going to use a different variable here? Where ID, oh, okay, is the name and the server concatenated with the hashtag in the middle for uniqueness. We can't have 2 Blood Warrior 123s on the server. For example, Blood Warrior 123 and server 1 would make the ID Blood Warrior 123 hashtag server 1. Okay. name plus hashtag plus server. Invalid syntax. Did I skip a comma? Oh, I have a semicolon in place of a colon. That won't help. Okay, that looks good. So to summarize the syntax for creating a dictionary, and also summarizing that I did return and then entered the value that I wanted to return, which in this case is a dictionary. So we have an opening curly brace, some value. It could be a string, it could be a number, it could be something else, but it can't be anything. It has to be an immutable value. And then that's called the key. And that's followed by a value, which in this case comes from the function definition. Duplicate keys. Because dictionaries rely on unique keys, you can't have two of the same key in the same dictionary. If you try to use the same key twice, the associated value will simply be overwritten. Assignment. Assume the same assignment we had before, but now another developer has introduced some bugs with multiple keys in the dictionary. Level equals 1, rank equals 2. Remember, the get character record function takes a character's name, server, level, and rank. It should return dictionary with 5 fields. I think we just have to take away this thing where it said level is 1. Hey, an F string. That's clever. Okay, yeah, that was all we needed to do there. Accessing dictionary values. Dictionary elements must be accessible somehow in code, otherwise they wouldn't be very useful. A value is retrieved from a dictionary by specifying its corresponding key in square brackets. The syntax looks similar to indexing into a list. So there's the syntax. We have car, we have square brackets, and we close the square brackets and we have the key inside. I'm going to take a screen cap here because I quibble with something here. What kind of brackets are used to index into a dictionary? It's square brackets, but I think curly should be curly braces, not curly brackets, maybe? Anyway, square. Setting dictionary values. You don't need to create a dictionary with values already inside. It's common to create a blank dictionary, then populate it later using dynamic values. The syntax is the same as getting data out of a key, just use the assignment operator equal to give that key a value. So names are Jack Bronson, Jill McCarty, and John Denver. Names dict equals braces, curly braces. For name and names, dot split returns a list of strings where each string is a single word from the original. Names array equals name.split. What if we gave it at someone who only has a single name? Anyway, here we update the dictionary. Names array at name 0 equals names 1. Okay, so it's a dictionary from first names to last names. What is the correct syntax to create a new key value pair in an existing dictionary? We see it here, dict, square bracket, key equals value. This is the same example. What happens if you assign a new value to an existing key? The value updates, so we overwrite the old value. What happens if you try to delete a key that doesn't exist in the dictionary? Deleting all dictionary values. You can delete keys using the del keyword. So del namesticked Joe. Deleting keys that doesn't exist. Notice that if you try to delete a key that doesn't exist, you'll get an error. I had to read that part because I didn't actually know that. Okay, what happens if you try to del a key that doesn't exist in a dictionary? You get an error. Counting practice, checking for existence. If you're unsure whether or not a key exists in a dictionary, use the incurred keyword. So if cars is Ford F-150 and Tesla 3, print Ford in cars, that's true. Print GMC in cars, that's false. Assignment. We need to be able to report to our players how many enemies are in their immediate vicinity, but they want the count of each enemy by its kind. Complete the count enemies function. It takes a list of enemy names. It takes a list of names as input. It should return a dictionary where the keys are all the enemy names from the list, and the values are the counts of how many times each enemy appeared in the list. How many times? This one is a little bit trickier. I feel like oops, what did I just do? For name in enemy names, we start with counterdict is empty value, and you might think that we could start by saying counterdict at name equals 1. Well, that works the first time we see name, but it doesn't work the second time we see name. You might also think that we could say plus equals 1, but that won't work the first time we see name because there will be no entry for dictionary name in there. So we have to check if name in counterdict something else something else. So if name is not in counterdict, then we create the key with a value of 1. Otherwise, counterdict at name plus equals 1. Let's run this and see if it looks reasonable. It does not look reasonable. I think because I have to return counterdict. So Jackal 6, Kobold 3, Soldier 3, Gremlin 1. That looks right. So let's submit it and check. Okay, good. Confetti. We start with an empty dictionary. Then we loop over the name in enemy names. Then if the name is in counterdict, then we can take the value at counterdict and increment it by 1, which remember is the same as saying counterdict at name equals counterdict at name plus 1. Otherwise, we create a new entry at counterdict at name and set it to equal to 1. Finally, we return the counter dictionary. Iterating over a dictionary in Python. Okay, we have an example with fruit sizes. Apple is small, banana is large, grape is tiny. For name and fruit sizes, size equals fruit sizes of name. Printf name, name, size, size. Apple size small, banana size large, grape size tiny. Assignment. We need to display on our players' screens what the most common enemy in a given area of the game map is. Complete the get most common enemy function. It should iterate over all the enemies in the dictionary and return the name of the one with the highest count. Note it's a dictionary of enemy name to count. Tip, negative infinity. When you're trying to find a max value, it helps to keep track of the max so far variable and to start that variable at the lowest possible number, negative infinity. Max so far equals float negative infinity. You also want to keep track of the enemy value associated with the maximum count. I would set the value for default for that variable to none. So given that hint or tip, and max name equals none. So for enemy, what is it? It's enemy name in enemies dict. Enemy count equals enemies dict at the key of enemy name. There is another way to do this, but I think I'll just stick to the way they've shown for the course. Enemy count equals enemies dict of enemy name. If enemy count greater than max so far, then max so far equals enemy count and max name equals enemy name. What do they want us to return? Return the name. Try this one. We have an error. What did I do wrong? Dict object is not callable. Oh, I didn't need to call that. Using dict, jackal 2 gremlin 7, most common gremlin, most common soldier. Okay, submit that. Confetti. Ordered or unordered. As of Python version 3.7, dictionaries are ordered. In Python 3.6 and earlier, Python dictionaries were unordered. Because dictionaries are ordered, the items have a defined order and that order will not change. Unordered means that the items used to not have a defined order, so you can't refer to an item by using an index. The takeaway is that if you're on Python 3.7 or later, you'll be able to iterate over dictionaries in the same order every time. This seems to be implying that you can, that in later versions of Python, I don't know what version of Python we're dealing with here, but let's just say D equals 1, A, 2, B, oops. And what if we try to, see, we can't, I guess if we could say for key in D, print D at key. So we can access them in order, but my point is we can't access them by index. Anyway, Python dictionaries before 3.7 were unordered. Okay, take a drink of water before we get into sets. Okay, Sets are like lists, but they are unordered and they guarantee uniqueness. There can be no two of the group of the same value in a set. Fruits equal apple, banana, grape. Print type of fruits, class set. Print fruits, banana, grape, apple. Notice that it's in a different order because the order is not guaranteed. Adding values, fruits.add pair. Empty set. Because the curly braces syntax creates an empty dictionary, to create an empty set, just use the set function. Fruits equals set. Fruits.add pair, print fruits, it's pair. Iterate over values in a set. Order is not guaranteed. Fruits equals apples, banana, grape. For fruit in fruits, print fruit, prints banana, grape, apple. Assignment. Complete the remove duplicates function. It should take a list of spells that the player has learned and return a new list where there is at most one of each title. You can accomplish this by creating a set, s equals set. Notice I don't want to write set equals set because set is a special word that refers to the set data type. And we don't want to overwrite that with our variable name. Creating a set, adding all the movies to it. Oh, there's a typo. You can kind of see the history of this course, that it used to be a list of movies. You can accomplish this by creating a set, adding all the movies to it, then iterating over the set and adding all the movies back to a list and returning the list. It makes no sense to learn a spell twice. Once it's learned forever. What if it's forgotten, though? Then you might want to relearn it. Anyway. I go along and say, for spell in spells, and I add the spell to my set S. Then for spell in S, and here we can use spell in two different places because it's only valid within the for loop. So that's okay. I have an output list, t equals empty list. And the function is append. And we return the list of unduplicated things. Eldritch Blast, Fireball, Sunburst, Water Gun. Water Gun. Okay, submit. Sets quiz. Sets are like lists. Okay, this is the same information from before. How do I remove an item from a set? Oh, it's down here. Fruits.remove. My set.remove of item. Sets quiz. What is the type of my val in the following statement? Val equals curly braces. That's a dictionary. Sets quiz. Which would be a good use of a set? To store all the enemies in a game by difficulty, to store all the possible spells in a game, to store ID user pairs. Well, not to store ID user pairs because sets just contain individual values. It's not great for storing all the enemies in the game by difficulty because, again, you have the you would need the enemy name and its difficulty, but all the possible spells in a game, that's a good one for it. Okay, we're on to errors. Good. Errors and exceptions in Python. You've probably encountered some errors in your code from time to time, and if you've gotten this far in the course. In Python, there are two main kinds of distinguishable errors: syntax errors and exceptions. Syntax errors. You probably know what these are by now. A syntax error is just the interpreter telling you that your code isn't adhering to proper syntax. This is not valid code, so it will error. If I try to get to run that sentence as if it were valid code, I'd get a syntax error. This is not valid code, is syntax error, invalid syntax. Exceptions. Even if your code has the right syntax, however, it may still cause an error when an attempt is made to execute it. Errors detected during execution are called exceptions and can be handled gracefully by your code. You can even raise your own exceptions when bad things happen in your code. Back before, when I had I had not defined that string, I was thinking in the back of my head I could raise a not implemented error, but it didn't need to do that at the time. Python uses a try except pattern for handling errors. So the classic example, dividing by 0. Try 10, divide by 0, accept exception as e, printf, exception exception accepted 0, e for exception. The try block is executed until an exception is raised or the try block completes, whichever happens first. In this case, a divide by 0 error is raised because division by 0 is impossible. The except block is only executed if an exception is raised in the try block. It then exposes the exception as data, e in our case. One second. It then exposes the exception as data, e in our case, so that the program can handle the exception gracefully without crashing. Assignment. One of the calls to get player record is throwing a player ID not found exception. Change the code to safely make each call with a try except block. If an exception is raised, just print it. I don't think we need a separate try catch block for each call. So let's just make it all inside one block. And we're using the base exception here, which maybe isn't the best practice, but we'll do it for now. Oh, maybe I am supposed to do each one in a. Maybe I am supposed to do each one in its own try except block. Let's do it that way. Okay. So again, we try to do something in code, something that might cause an error. And then we tell Python that try to do that, but if there's an exception, then call that exception variable e, and then do something else, in which case this is just going to print the error. Try again. Oh no. Was I supposed to do it the other way? No, that didn't help. Oh, just print it as it is. Darn it. Lost my winning streak. Oh well. Okay, now we're going to review try except. The try block is executed until an exception is raised or it completes, whichever happens first. In this case, the divide by zero error is raised because division by zero is impossible. The except block is only executed if an exception is raised in the try block. It then exposes the exception as data ENRK so that the program can handle the exception gracefully without crashing. If no exceptions are raised in the try block, then the except block won't execute. If an exception is raised outside of a try block, the program crashes and prints the exception. Raise your own exceptions. Errors are not something to be scared of. Every program that runs in production is expected to manage errors on a constant basis. Our job as developers is to handle the errors gracefully and in a way that aligns with our users' expectations. We'll skip the video for now. When something in our code happens that we don't expect, we should raise our own exceptions. For example, if someone passes some bad inputs to a function we write, we should not be afraid to raise an exception to let them know they did something wrong. An error or exception is raised when something bad happens, but as long as our code handles it as the users expect it to, it's not a bug. A bug is when code behaves in ways our users don't expect it to. For example, if a player tries to forge an iron sword out of bronze metal, we might raise an exception and display an error message to the player. However, that's the expected behavior of the game, so it's not a bug. If a player is able to forge the iron sword out of the bronze, that may be considered a bug because that's against the rules of the game. Syntax for raising exceptions. Raise exception, something bad happened. Assignment. If a player ID is passed into the getPlayerRecord function, we need to raise our own error to alert the caller of the function that the player they're looking for doesn't exist. The exception should say player ID not found. I guess this is else. Except that we haven't done an elif syntax, so I guess it's just the return statements will take care of program flow, so it'll never get here if any of those work. So if it gets here, then we say player ID not found. Okay, that makes sense. Raising exceptions review. Software applications aren't perfect, and user input and network connectivity are far from predictable. Despite intensive debugging and unit testing, applications will still have failure cases. Loss of network connectivity, missing database rows, out-of-memory issues, and unexpected user inputs can all prevent an application from performing normally. It is your job to catch and handle any and all exceptions gracefully so that your app keeps working. When you are able to detect that something is amiss, you should be raising the errors yourself in addition to the default exceptions that Python interpreter will raise. So raise exception, something bad happened. Which keyword creates a new instance of an error to be caught in Python? That is, from here, it's raise. Good code doesn't need to handle errors. It should be error-free. That is false. There are going to be errors because the world is unpredictable. Different types of exceptions. We haven't covered classes and objects yet, which is what an exception really is at its core. We'll go more into that in the object-oriented course that we have lined up for you next. For now, what is important to understand is that there are different types of exceptions and that we can differentiate between them in our code. Try 10 divided by 0, except 0 divisibility error, print 0 division. Except exception, print unknown exception. Try nums 0, 1, print nums 2, except 0 division error, print 0 division, except exception, print unknown exception, which will print 0 division, unknown exception. Basically, 0 division error is a more specific type of exception. and we check for it first. But if we don't find it, and we won't find it in this case, then we go to the general exception. Assignment. The getPlayerRecord function can now raise two different types of exceptions. One is an index error, the other is a custom exception message of the base exception class. Complete the handle getPlayerRecord function. It should return the result of getPlayerRecord, but if an index error is raised, it should print index is too high. Otherwise, if any other exception is raised, it will just print the exception itself. Oh, I see. It says handle getPlayerRecord of player ID. We try getPlayerRecord of player ID. Except if it's an index error as E, then we will print index too high. Oh, we don't need as E. Except exception print E. Run this. None, 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 index too high, negative IDs are not allowed. That's the, okay, that's our, index too high was the index error, negative IDs are not allowed was the exception that we didn't know anything about. Try again. Oh, we need to return getPlayerRecord of ID. Okay. In this code sample, what will happen? Raising exceptions review. As you notice, there are many kinds of exceptions. Many specific exceptions are built into the language like index error and zero division errors, and all exceptions count as the parent exception type. If you're interested in the official documentation on all the built-in exceptions, you can find a list here. We'll look at that later maybe. Refer to the following code for the question. Try raise exception zero division, accept zero division error as E, print 0. In this code sample, what will happen? Well, we're first going to raise the exception, then we're going to catch that same exception as E, but we're not going to print zero division. We're just going to print 0 because that's what the code tells it to do. Oh, I got fooled. I got fooled. It's nothing. The program will crash with an on-caught exception. Because it raises an exception with the text zero division, but zero division error is a different kind of exception. So we don't catch the exception that was raised. And yeah, okay, the program will crash with an on-caught exception. Oops. Okay, we have a new example. Try raise exception zero division, accept zero division error as E, print 0, accept exception as E, print other. It will print other this time. Good. Refer to the calling code for the question. Try 10 divided by 0. That will raise it's a zero division exception. Accept exception as E, print other. It will print other. Good. Okay, time for the BRB screen. Okay, we're on to chapter 11, which is challenges. It says, in this chapter, we are going to practice applying the skills and concepts we learned while building Fantasy Quest. Number sum. Write a function called number sum that adds up all the numbers from 1 to n. For example, number sum of 5 is 1, 2, 3, 4, 5 is 15. Number sum of 3 is 1 plus 2 plus 3 is 6. I could do a list comprehension, but I'll stick to things we've learned so far in this course. So for I in range of 1 n plus 1, result equals 0, because we start, when we're taking a sum, we start at 0. result plus equals I, return result. Let's check that. Wait. The sum of 1 to 3 is 3? That's not right. Oh. Huh. That's a bug. Plus equals I. 1 to 3 is 6. 1 to 5 is 15. Okay, check. Minimum number in Python. Write a number to find min that finds the smallest number in an array. Find min 1, 3, minus 1, 2 goes to minus 1. Find min 18, 3, 7, 2 goes to 2. And they're going to tell us now about positive infinity. Since you're trying to keep track of the smallest number, start with a really big number. Python has a built-in constant that represents positive infinity. Let's say minimum because min is already defined as a function. We start with minimum is a float of INF. And then we say for num in nums, if number is less than minimum, minimum equals number, then we return minimum. That's all there is to it. Except I did something wrong. Name number, oh, minimum equals num. Okay, that looks good. To review this one, we start with a really big number so that any actual number is going to be less than that, so that the original value for minimum won't mess up our final result. Remove numbers. Write a function called remove non-ints that removes all non-integer types from an array. You can check the type of a variable using type function. Now, the way I'm going to do this is iterate for possible num in nums. I don't want to be removing things from an array while I'm iterating over that array. So instead, I'll make a new output array. So if type of possible num will int, output.append possible num, and finally we return output. Let's check that these look right. 300 to 7. Yeah, that looks right. Next up, factorial. Complete the factorial function. It should calculate the factorial of a number. A factorial of a number is the product of all positive integers less than or equal to that number. For example, 4 factorial is 4 times 3 times 2 times 1 equals 24. The exclamation symbol denotes a factorial. Tip, a special case for 0. The value of 0 factorial is actually 1. This keeps factorials consistent with the convention for an empty product. Not sure exactly what that means, but I'll start with if num equals 0, return 1, else. Actually, we don't even need an else because control flow says that if number is 1, return 1, but if number is not 1, then we'll end up on this line and we can just proceed. So for num in for x in range of 1 comma num plus 1 because we want it to be inclusive when it gives out the numbers. We start with result equals 1. Oh, interesting. We don't actually need to check if num equals 0. But it's probably a good thing to do. Result times equals x. Return result. The factorial of 14, it says, is this big number. Factorial of 5 is 120. That sounds right. Okay, got that one. Area sum. Complete the area sum function. It accepts an array of rectangles where each rectangle is a dictionary that has the following structure. The height 5, width 6. The function will calculate the area of each rectangle, then sum them all up in the result. So let's do area rect of A comma B. Def area rect of A comma B, return A times B. I'm not sure that's really necessary, but it's probably a good idea. For rectangle in rectangles, result, we'll keep track of result in a variable that starts at 0. Result plus equals area rect of rectangle, and we have to access height, comma, rectangle width. Now, if you're quick, you'll notice that I made an error. Rectangas is not defined. I made multiple errors. For rectangle, okay, copy paste means I get things spelled right. Sum is none because I forgot to return anything. Okay, those are numbers. We'll say that's good. Got it. FizzBuzz. FizzBuzz is a commonly overused little toy program that comes up in entry-level interviews. Write a program from scratch that loops over all the numbers from 1 to 99 inclusive and prints them. So we'll start with for num in range 1 comma 100. Remember, range function is exclusive at the second number. So that's why I'm going to 100 there. If a number is a multiple of 3, instead of printing a number, print fizz. If a number is a multiple of 5, print buzz. If it is a multiple of 3 and 5, then instead print fizzbuzz. Let's see, which way that I know do I want to do this? Let's start by checking if num mod 3 equals 0. So that's if it's that means it's a multiple of 3, and num mod 5 equals 0. Print is buzz. So we'll cover that case first. Elif num mod 3 equals 0. Print is. Elif num mod 5 equals 0. Print buzz. Else print num. So this may not be the most efficient way to do it, but I think it's the way that's easily explainable. We start by checking if it's both divisible by 3 and 5, or it's a multiple of both 3 and 5. Then that's fizzbuzz, and we have an else if here. So if in this case we know that it's not divisible by 5, well, we know it's not divisible by 3 and 5. And once we find that it is divisible by 3, or that it's a multiple of 3, then we can print fizz. Then we know we can print only fizz. And similarly, if we know that at least one of these is true, but only one. Anyway, this should work. Yep. Cool. Array division. Write a function called divide array that takes an array and a number as an input. The function creates a new array that contains all the elements of the original array except they have been divided by the second input. Well, it's tempting to write nums, return nums divided by divisor. But just for interest's sake, let's see what that returns. Unsupported operand types for divide, list, and int. You can't take a list and divide it by an int. So instead, we have to make a, let me see. We can do this in place in the nums array. Go for I in range of the length of numbers. Numbers at I equals nums at I divide by divisor. Do we want to integer divide? Make sure you're appending the raw float values. Don't round or cast the numbers to integers. Okay. I need to return nums. Notice that I can't just say for num in nums because I need access to the position of the array to save the number back into there. Try again. Oh, what did I do wrong? Given nums 1, 5, blah, blah, and divisor 5, 1, 5, blah, blah, was returned. What? Am I missing something obvious? Oh, shoot. I think this is a bug in the course. Still wrong. Now what's wrong? For num in nums, my nums something is weird. What am I missing here? Let's just reset the code. There it goes. There's definitely something wrong with what I'm doing here. Oh, return nums. That's the problem there. Okay. I must be getting tired. But I still have a problem with, I don't understand what was wrong with for I in range, for I in range of length of nums. Divide by divisor. If I say just put in a dummy number here, if I do plus divisor, oh no. I see the problem. Oh my. I wasn't supposed to change the values in nums. See, given nums equals 3, 4, 5, it was actually given nums equals 6, 8, 10. Because lists are mutable. Okay. So the problem here is that it printed the wrong output because the given nums number was wrong. Okay. I'm done with that one now. Join strings. Write a function called join strings that concatenates all of the strings it passes as its inputs, end in an order, and adds a comma between. Well, this is a simple join, comma, dot, join strings. Return, comma, dot, join strings. Okay. Shout out to SC2, StarCraft 2. Okay. The Zen of Python. That's nice that they're putting that in here. Tim Peters, a longtime Pythonista, describes the guiding principles of Python in his famous short piece, The Zen of Python. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules, although practicality beats purity. Errors should never pass silently unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it, although that way may not be obvious at first unless you're Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of those. Quiz. Simple is better, blank is better than blank. Simple is better than complex, taking it directly from the text. It's okay for special cases to break the rules. Well, this is a tricky one. Special cases aren't special enough to break the rules, although practicality beats purity. But practicality says that it's simpler to go with the first statement, so I'll say false. An implementation that's easy to explain is a good idea, maybe. There should be one obvious way to accomplish a task. Which language? Why Python? Here are some reasons we think Python is a future-proof choice for developers. Easy to read and write. Python reads like plain English. Due to its simple syntax, it's a great choice for advanced concepts like AI. This is arguably Python's best feature. Popular. According to Stack Overflow Developer Survey, Python is the 4th most popular coding language in 2020. Free. Python, like many languages nowadays, is developed under an open source license. It's free to install, use, and distribute. Portable. Python written for one platform will work on any other platform. Interpreted. Code can be executed as soon as it's written because it doesn't need to take a long time to compile like Java, C++, or Rust, Releasing code to production is typically faster. Why not Python? Python might not be the best choice for a project if the code needs to run fast. Python code executes very slowly, which is why performance-critical applications like PC games aren't written in Python. If the code base will become large and complex. Due to its dynamic type system, Python code can be harder to keep clean of bugs. Or, if the application needs to be distributed directly to non-technical users, they would have to install Python in order to run your code, which would be a huge inconvenience. Which language typically allows for code to be released most quickly? Released most quickly is Python. The best reason to use Python is because its code runs fast. That is false. Python 2 versus Python 3. One thing that's important to keep in mind as you continue your Python journey is that Python ecosystem suffers from split personality syndrome. Python 3 was released on December 3rd, 2008, but over a decade later, the web is still full of Python 2 dependencies, scripts, and tutorials. In this course, we used Python 3, just like any good citizen should these days. One of the most obvious breaking changes between Python 2 and Python 3 is the syntax for printing text to the console. Python 2 print space hello world. Python 3 print paren hello world. Assignment: update the code from Python 2 to Python 3 syntax. What happens if I run it just like this? Oh my. Oh, did you mean print Python 2 really needs to die already? I thought that was actually part of the error message, but it's just arbitrary text. Did you mean print arbitrary text? Okay, it's not actually part of the error message. That's disappointing. Not disappointing, but it's kind of less fun than it could be. Okay, fix the bug. Run. Python 2 really needs to die already. Got it. Should you use Python 2 or Python 3? As you've probably guessed, you should always use Python 3 going forward. Python 2 and Python 3 are similar, but Python 3 contains significant changes that are not backwards compatible with the 2.x versions. Python 3 code is always backwards compatible with Python 2. That is false. Okay, that's it for that course.